doing things appropriately in order to achieve a wide manner of goals and to communicate a wide manner of signals. Now, this is a little bit different, of course, in the time of coronavirus because we're doing a lot of this via our screens, but we are still watching other people in actions and with those in our immediate surroundings for communicating with our bodies, and we're able to read their intentions and to achieve mutually beneficial outcomes. So that's all well and good. We're learning a lot about how the human brain is able to navigate these social signals in our world. And of course, we've evolved over millennia to make sense of other people. But a really interesting question that I've become interested in the past 5 or 7 years is, it's great that we can understand humans and we're really good at this, and understanding how it is we can do this is a fascinating challenge. But what is going to happen as our daily lives and our social worlds become ever more populated with artificial agents? And by the type of artificial agents I'm particularly interested in are social robots. So these are the types of robots that we keep reading about in the news and hearing about in all sorts of different contexts as the robots that are going to come help us in our schools and our hospitals, perhaps even our own homes and our workplaces. And they're not necessarily here to help us build cars or manufacture products, but instead they're here to help us in social contexts. And you can see that in all these really close quarters that we're going to be working and living with robots, we're going to have to be able to understand and communicate as well with them in these really rich social ways that we've evolved so well to do with humans. And my question is, from a neuroscience perspective, how is it that we're going to be able to do this? And how is the human brain equipped or not to help us achieve seamless social interactions with artificial agents, and especially embodied robots like you see in these pictures? So if I put my research questions in context, and again, hopefully you'll see in these setup slides what the connection is between kind of my human neuroscience and social neuroscience and cognitive neuroscience training and how that relates to social robotics. I'm really interested in this relationship between vision and action. So what it is, or perception and action, what it is that we kind of perceive in the world around us, what we see other bodies doing, and how that kind of relates back to us, our own bodies and our own experience. So if we take this really simple relationship as a starting point, the brain regions that I'm particularly interested in, and if you're interested in the neuroscience, great. And if you're not so interested in what brain regions are, what they're called, please don't worry about this. This isn't super important for the details of the talk. But we're really interested, my team and I, in a group of brain regions known as the Action Observation Network. And they're kind of illustrated in this cartoon brain. You can see a left hemisphere picture here on the right. And the types, or the brain regions specifically that make up this action observation network include parts of the premotor cortices, which are kind of in the pinks and purples there, the inferior parietal lobule extending along the interparietal sulcus, which you'll see in oranges, and parts of the occipitotemporal cortex in green. So kind of specific regions right on the surface of the brain that seem to be really important in how it is we perceive and make sense of other people we see moving around us in a social world. So over the years, I've asked a lot of questions about how our different types of experience are going to shape engagement of this action observation network. And the types of experience that I've tested, that I've looked at, and that I've tried to evaluate in laboratory experiments include motor experience. So by that, I mean, if people learn to do new actions, how does that shape how they see other people doing those actions? We also look at visual experience. Social experience, and this is where robotics come in. So we're kind of understanding the similarity between self and other. We've done a lot of work as well with a fantastic researcher who's currently based in Pune, India, on aesthetic experience as well. And that's Dr. Kohinoor Darda, who might be joining us actually in this talk this evening. We all have also looked at linguistic experience and affective or emotional experience. So we can ask questions about how all of these different types of experience shape how it is we're seeing other people, how our brains are supporting our understanding of other people that we encounter in this really rich social environment. And again, I keep saying people, but this social experience question allows us to start to tap into what might be going on when it's not just people we're encountering, but also artificial agents such as avatars and robots. So the tools that my team and I use to address these questions are many, and they mainly focus on a combination of brain imaging, brain stimulation, and behavioral measures. And by using these different ways of looking at the human brain and studying how brain responses link up with our behavior, we can start to get a really clear picture about how experience is shaping our perceptions of others around us, and kind of how individual differences are driving these as well. We also, because we're interested in this question of experience, we make a lot of use of intensive training procedures. So we bring people into the laboratory and we either teach them to do something new, like how to dance a certain dance style, or how to create objects like tie a knot. Or we have them come into the laboratory and spend a long time interacting with robots, or we send robots home with people. And we're always interested in how people's brains and behavior and perceptions more subjectively change kind of before you've had any experience at all that we're interested in giving you, and after you've spent days or weeks with different types of experience. And finally, we've spent a lot of time working with kind of experts in kind of more unusual complex parts of the social world. So we spend a lot of time with expert dancers. We've done some work with expert musicians and acrobats and circus performers as well, because we're really interested in how highly complex movements shape our brain and behavior. And also the work we're doing with artificial agents is obviously quite unusual, and it's not something that all of us have experience with. And it's certainly not something that we've evolved to spend time with, but by kind of looking at these really extreme examples of different agents or different actions or different types of expertise, again, we can understand a lot more about how the brain is changed and shaped by training and experience over time. So today, I'm going to talk to you about kind of 3 different themes and just give you a little bit of of research that my team has worked on. And this is really kind of broad brushstrokes overview. We're not getting into great depth. There'll be references for the papers. So if you are interested in reading them, they're all open access. They're all openly available on my lab's website, if not through kind of Google Scholar and other means. And you can always email me if you'd like to read anything in more depth. So the first question we're going to try to answer is how the human brain, which again has evolved for perceiving and interacting with people, might be used in a similar or a different way when we're encountering robots. Next, I'll try to address how different features of artificial agents, such as what they look like or what we might know about them, shape our interactions with them. And finally, I'll talk about a little bit more of our recent work, which we're looking at asking how spending time with robots, so this kind of long-term experience question, starts to shape how we might feel and perceive these robots, and particularly in an empathy-related way in this final study. So one of the theories that I think is really interesting for building bridges between disciplines like social neuroscience and human social cognition, and fields that are more related to robotics, and this in particular social robotics, is a theory known as the like-me theory. And this theory actually comes from developmental psychology from nearly 20 years ago. And basically what this theory says is that we as humans are hardwired to be seeking out and trying to understand the basic similarity between me and you. So this drive to understand how you're different than me or you're similar to me, and kind of what our common ground is, this forms the foundation of social cognition. And again, we know that social cognition is really important for almost everything we're trying to achieve with other people in our daily lives. So kind of the brain is constantly trying to evaluate this question of how like me are you, or is this agent that I'm encountering? So there's been lots of research that has looked into this and has provided a lot of support for this like me theory, including work that's looked at how the brain is responding when you see a person versus a monkey versus a dog perform different actions. And not that it makes a ton of difference to this talk, but essentially what this brain data show is that the brain is more engaged when you see an agent that is most like you. So the person is a little bit less engaged for the monkey, which is not so much like you, but it's even less engaged for a dog, which the authors argue is even less like me or like you. There's also been some really early work done looking at kind of robot arms and human arms grasping objects. And again, what this data shows is that the human arms, which are most like me, show more engagement of this action observation network, which I just showed you. And finally, work that I've done with my colleagues, looking at expert dancers and kind of looking at familiar versus unfamiliar choreography, we also show that there's kind of much more engagement of this action observation network when you see movement that's familiar, that's like you, that you've done with your own body, compared to movements that you've never actually practiced before. These are just 3 of many examples. So we know that this dominant model of social cognition proposes that parts of this action observation network, which are sometimes used somewhat synonymously with what's been referred to as the social brain, we know that this action observation network certainly contributes to social processing. So this dominant theory is that these parts of the brain are really going to be preferentially engaged when we see other agents and actions that are similar to ourselves. So a question becomes then, okay, we see a human having a cup of coffee. We know that these brain regions are going to be engaged, but to what extent are we going to see these same brain regions being engaged, or will it be different brain regions when we encounter, for example, a robot having a cup of coffee? There was some evidence that was kind of coming out several years ago that says that maybe this like me hypothesis, even though it's really elegant and it makes a lot of sense from kind of a top level perspective, maybe it's a little bit too simplistic, and the brain isn't just so kind of hardwired to only be seeking out other humans, other things that are, or agents that are similar to ourselves. And maybe there's, something else going on. So we wanted to dig into this in more detail. So yeah, our aim here was to try to test the limits of this socialness with a few different experiments using behavior and brain imaging tools. So hopefully these videos will play okay, but what we used was something that's really quite common in human neuroscience or human social neuroscience research, which is a 2x2 design. And essentially we're going to ask questions about what's going on in the brain when you see a human or a robot do 2 different types of actions. So actions that are kind of more smooth and familiar and human-like. We had a human break dancer who you can see in the top left cell kind of perform a few different movements. And then we used stop motion cinematography to get a little Lego action figure to do similar movements. But then we also had our very expert human robot dancer perform movements that looked much more rigid and robotic. And then we animated our Lego action figure on a frame by frame basis to do the same thing. And in this way, we're able to ask questions about the form of an agent and the kind of motion that an agent might take, and we have a form that is very like me, so it's human, and we have motion that's very like me, so it's human-like, and then we have motion that's very not like me, so this rigid robotic, and we also have a form that's very much not like me. So we kind of can play these like me, not like me aspects and what something looks like and what something moves off against each other. So these details aren't super important. They just show that we had people watching these videos in a succession in the scanner, and they weren't just watching them, but after every so often, a question mark would appear, and participants would see a short little video clip that was just a little excerpt from what they'd previously seen, and their task was to decide whether that little 2-second probe video came from the video they just previously saw, or was it from a different video. And this is a good way for us to make sure that people are paying attention while they're scanning their brains, and also that they're not falling asleep, which happens. And this plot, again, all you need to look at here is that these bars are all really high and they're all really close to each other. All this tells us is that people aren't preferentially paying more attention when they're seeing the little robot figure dance or the human dance, or when they're seeing the kind of more human-like motion or robot-like motion. So everything was pretty similar and at a really high level. So what we found in this study, just to give you kind of, again, the top level picture, was that what we'll first do is just kind of look at what's going on in the human brain when you're watching any sort of movement. And this first thing I'm going to show you is just the motion contrast. So when you're looking at the different robot motion, kind of rigid motion versus the more smooth human motion. And we see that when people are watching any kind of motion compared to just that white fixation cross on a black screen, we get really, really robust engagement of the entire action observation network across both the left and the right side of the brain. That's what I'm showing you in this picture here. That's fine. When you're watching something move on the screen like this compared to a black screen, you'd expect to get this. But of course, what's much more interesting in allowing us to evaluate this like me hypothesis is what goes on when we compare this kind of more natural, familiar like me motion to this really rigid, unfamiliar unlike me motion. Here, according to the hypothesis, we should see much more engagement of this action observation network when something's familiar and natural compared to being really unfamiliar and robotic. But just to skip to the chase, what we see is the exact opposite of this. What the brain regions are showing us is that when you're watching the more familiar natural dance movement compared to the robotic movement, there's nothing going on in these kind of action observation networks, but instead we see some engagement right in the very back of the brain in visual regions. And the inverse contrast, when we look at this kind of unfamiliar, unlike me robot motion compared to the like me motion, here we see really robust engagement of these action observation network regions. So not at all what we were expecting and not at all what the theory would say, but there's clearly something quite interesting going on. And the human brain isn't just, hardwired and evolved to just kind of respond most robustly when we see, actions or agents that are most similar to ourselves. I'll show you just one more really quick result from this because I think it has some interesting implications for how our perception, our social perception develops. So we did we did several more contrasts, but one more I'll show you here is we could compare what's going on in the brain when you see a person moving like a person, which makes sense, and a robot moving like a robot, which also makes sense, compared to a human moving like a robot, which is kind of weird, and a robot moving like a human, which is kind of weird. So we can call this like kind of the congruent pairings of form and motion compared to the incongruent. And when we do this, we see this really nice engagement of a part of the temporal parietal junction, which is, hopefully you can see that little red and yellow blob right in the middle of the brain there. And that seems to really care about human and robot form and motion being matched. And it doesn't really respond as much when they're kind of mismatched and they're kind of going against each other. We then ran the same study using a slightly different brain imaging technology known as functional near-infrared spectroscopy, which you can see right here. I should say as well that in our first study, this was with a bunch of young adult participants, so people who are between the ages of about 19 and 30. Then we reran the study using this slightly different brain imaging technology with a bunch of 4-month-old infants. So it looks like what you see in this picture here, and these are tiny babies that have very little experience with the world, let alone seeing robot movements or that many human movements or dancing movements because they're so young. But we are interested in the extent to which we might be seeing kind of similar or different patterns, or that the brain might be kind of hardwired from birth to respond preferentially to human versus robot actions. And all I'll show you from this study is that we see a very, very similar pattern of findings within a set of kind of brain recording devices over the same part of the left hemisphere that we see in the kind of left side of the screen with our adult brains. And again, in the young infants' brains, they seem to also be kind of making sense of human motion and human form, which makes sense. They'll have seen that the most. And they seem to also be pairing together robot form and robot motion. That could just be unfamiliar form and unfamiliar motion. But when the two are crossed, this part of the infant's brain doesn't respond nearly as robustly. So all of that to say, by kind of using similar paradigms with different ages and different populations, we can begin to get an idea about how much of this is experience across the lifespan and how much of this is something that we're kind of born with seeing in a certain way. And this kind of just gives us first glimpses towards that. And that just shows that this pattern is really quite similar in the same parts of the brain, in the adult brains and in the very young infant brains. So our kind of main answers from this first question is that this like me hypothesis, again, is really luring, but it doesn't seem that the human brain is that rigidly hardwired to respond most robustly to agents or actions that are strictly like us. And this flexibility that we see raises all sorts of really interesting possibilities in terms of robotics engineering and design, and kind of a take-home point that I'll return to several times over is that perhaps spending all this time trying to make robots that look like us or move like us isn't actually the most important thing from a human interface, human user perspective. There's kind of far more interesting or flexible processes going on in the human brain to mean that perhaps some of that R&D could be better invested elsewhere. That's coming from a human neuroscientist, a social neuroscientist, not a robotics engineer. So very happy to have that debate with people who think differently. Moving on to the next question, and I realize, oh no, I do have timing right there. Yes, I want to make sure we have plenty of time for questions. The next question we asked, so that first study we looked at like what goes on in the brain depending on what you're seeing. But in this study, we wanted to ask some questions, not just about what you're seeing in an artificial agent or in a robot, but also what you bring to the table in terms of your beliefs or what we tell you to believe about a robot. So we know that stimulus cues are what a robot looks like, so how it moves, what shape it takes, all of these kind of physical attributes can and do influence how we perceive robots, though precisely how is a little bit mixed. But there's also this really important point that what you've been told about a robot or what you believe about a robot, that can also really strongly influence how you approach it and how you might be interpreting its behavior. So for anyone who's seen the film Austin Powers, I'm probably dating myself for how old this film is now. If you've seen it before, you'll know that this isn't just our protagonists in the middle here surrounded by some nice women, but they're actually deadly robots with weapons hidden in specific places so that if you didn't know that just looking at them, you would certainly know that once you interacted with them and saw those weapons come out, and that of course would make you approach them very differently in the future. So what we did in this study was something a little bit different. I'll try to break this down as simply as possible because it might seem a little bit crazy, but it's actually a pretty simple design. Again, I should say that before we had anyone come into the laboratory and have their brain scanned, because it was another brain scanning experiment, we first showed people kind of a really long, like half-hour or 20-minute elaborate documentary that explained two different types of how films are made. So here, we're really interested in having people watch little video clips and telling them that these clips come from human origins. So we had a person in a motion capture suit, like everyone's probably seen in films like Avatar and Polar Express and many others. So there's humans at the core. We use humans to animate these kind of virtual characters. So we explained how that works in our video. Then we also explained a different type of computer animation called computer keyframe animation, where humans are essentially completely taken out of the equation and it's computer algorithms only that are cranking through and deciding how to animate how figures should work. So we make this really strong distinction between human-driven animation and computer-driven animation. And show people a bunch of videos, and we tell them before half of them, the videos you're about to see come from human origins. And for the other half, we say the videos you're about to see come from computer generated origins. Essentially, there's no humans involved. And again, in this documentary they watched previously, we explain precisely how these types of animation work. Now, of course, in the real experiment, in real life, all of the videos are the same, and they don't actually come from either types of animation we're speaking of. They're kind of a mix between the two, but people don't know that. And to kind of further help with our story, we tell people that this study was kind of funded by the German Film Commission. This was a study done in Germany, and the German Film Commission was really interested in understanding how these types of computer animation or these types of animation influence people's perceptions. So people watch a bunch of videos, and you can see some examples here. They're just really simple videos of either a human avatar or a robot avatar performing simple acts. There's about 10 different actions, like throwing a ball, putting pens in a pot, stacking some blocks, etc. Or we tell them that the videos that they're about to watch come from computer animation. And again, if you're watching closely or not even that closely, you'll see that they're the exact same videos. We just tweak people's beliefs about the videos in advance. So here we're able to understand a little bit more about what you believe about a video or a character that you see on screen, whether it has human origins or computer origins, and also does it look more like a human or more like a robot. So just to kind of quickly go through this, we see that interestingly, people's behavioral reports, they actually find that the ones that they believe have human origins to be much more pleasant to watch and the animation to be much smoother, even though it's the same, than the ones that they believe have computer origins. But there's no difference at all between the kind of funny looking white robot character and the man avatar. And what we see in the brain, again, the specific brain regions don't matter as much as just the main overall point, which is that we do see more engagement of kind of visual regions when you're watching a robot compared to the human, and there's a bunch of interesting reasons for that. But more interestingly, in this bottom row of brains, we see several brain regions, and most curiously, the precuneus, which is pointed out on the far left of that bottom left brain, as being more engaged when you believe that videos had human motion capture origins compared to computer animation origins. And this is really quite a striking and stunning finding in terms of suggesting that parts of the brain that we know are engaged with thinking about others' minds are also engaged when you just kind of believe that something has human origins. So our main findings here are that people report movies that they think or believe have human origins to be much smoother and more likable than movies that they believe are computer generated, even though they're identical. And not only is that what people kind of explicitly report about these videos, but we see that their brains seem to be backing this up and kind of engaging more, engaging regions more that are associated with thinking about others' minds when you believe something to have human origins compared to when you believe it doesn't have human origins. So again, I'd like to say that there's some potentially interesting implications for artificial agent design and development, especially in terms of managing people's expectations. So I'm going to give a little summary of findings so far, and I am looking at the time and I'm cognizant that we don't have a ton, so I might cut it off here after speaking to our moderators. I'll look at the chat too, because I can't have it all up at once. But what we can tell so far is that parts of the brain that we know are responsible for linking action and perception seem to respond to both humans and robots, and we're not actually seeing anything special about humans per se, which the like me hypothesis and lots of kind of social cognition research would suggest that we would really see these brain regions specialized for humans and humanness and human likeness. But we're not really seeing that. But we are seeing that other parts of the brain, and I've not shown you all these data, but this last study kind of was the tip of the iceberg of that. We see that parts of the brain that we know are really specialized for not just linking action and perception, but thinking about others' minds, those parts of the brain really do seem to be more biased towards humanness. So human cues to something having human origins. So we see that there is evidence for biological specialization for engaging with other people and not so much machines. So again, different parts of the brain, we're starting to get a much better understanding of how they fit together. So together, I'd like to suggest that these findings set the stage for using human neuroscience and tools and techniques that human neuroscientists and social cognition researchers bring to the table to examine and optimize the human side of human-robot interaction. There's a lot of research and development that's spent on what the robot looks like and what the robot does and how to make the robot ever more human-like. But I think getting a much better understanding of the dynamic nature of the human brain and human cognition can help us to engineer robots that are much more effective and much more readable in a social way when we engage with them in social contexts. So I'm just going to pause there for a second and check the chat. Oh, I don't have a cursor. I'm so sorry. Maybe you can tell me, how are we doing time-wise?
We have about 5 to 6 minutes through which I can take questions.
Perfect. I will stop there. I will stop screen sharing then. Perfect. Okay.
Well, we have received a lot of questions, not only in the webinar, but through a lot of our other social media channels. But before that, I would just like to say that this is such a fascinating talk as the world moves towards more interdisciplinary fields in general. The interface of social science, social neuroscience, robotics, and dance, as it turns out, was amazing to listen to.
Thank you.
Based on that, a question that we seem to be getting a lot is what actually inspired you to study such diverse fields as cognitive psychology, cognitive neuroscience, and robotics?
Great question. As you kind of alluded to there, I actually come from a dance background, actually a theater and a dance background, and I was always very interested in how we learn new movements and how we can transition from being kind of not so great at performing a movement to being really, really adept and expert and incredible, and kind of what's going on in that transition. So that was kind of the first thing I studied in cognitive neuroscience and social neuroscience. And then we started to use, about 10 years ago, robots as a control condition. So we're really interested in kind of social learning and social aspects, and whether there's something specific and special about seeing humans dance. And we thought we're going to use robots dancing as a control condition. But then that opened up an entire really interesting whole new world of questions, not just about robots as a control condition for human things, which actually might not be a great control condition as it turns out, but also all that's going on when we're interfacing with robots. So like in the past, I'd say, decade or so, we've been doing more and more and more, and almost not exclusively, we still do a lot with aesthetics and dance, but a lot with robots to kind of understand that learning aspect when it comes to engaging with robots and other artificial agents.
I see. That's amazing. Another question that we've been getting is, can innately human values like empathy and compassion be actually modeled or programmed into robots? And how difficult would a task like this be?
That's a very big question. I think that's a much better question to ask a robotics engineer, though I think it's an interesting question to ask people from neuroscience and cognition and behavior too. So that we'd probably have very different answers. I think it's very difficult or impossible with the technology and the tools we have now to model something as complex as empathy or compassion in an artificial agent. And I'm going to go so far as to say any artificial agent, whether that's an AI or an embodied robot. And of course, the embodied robot's going to be using AI to some description. And I think, again, the biggest reason why that's going to be so difficult is because it's such a dynamic and continually updating process in the human experience. And again, there are so many individual differences, and what you'll model in an artificial agent is going to be kind of like one small slice of that. So I think that's difficult. And again, I would come back and say, I think what's really interesting on the flip side is understanding whether humans can actually exhibit empathy and compassion towards artificial agents and how that's different, or what it shares or doesn't with how we feel towards other living entities.
That's it's a very interesting direction to go in, because another question that we've been getting is, recently on social media there's been an influx of robotic influencers or extremely humanoid robots. And based on your talks, the like me theory seems to not necessarily be explaining everything. And our audience would just like to know your opinions on that. Like, as robotics becomes more and more humanoid, do you see a change happening in either the theory or in robotics in general?
These are really good questions. Now, many people, yourself probably included, will be familiar with the uncanny valley hypothesis, which is a really interesting kind of theory that emerged back in the 70s, but the empirical evidence for it is really quite mixed. And it's something that, again, it's one of those theories that's instantly understandable and everyone gets the uncanny valley, which is this idea that we like robots or artificial agents more and more and more, the more like us they become. But once they get a little bit too close, we hate them and they are really creepy and we can't watch them anymore. There's this fantastic video of a new humanoid robot by Disney Research, which you can look up on YouTube, which people like get super creeped out by and say that falls right down the uncanny valley. So there is this kind of other theory. Well, there's many other theories, but the uncanny valley is another really big one that people are really familiar with and talking about all the time. Again, I think that these theories don't necessarily go against each other or contradict each other, but they kind of all contribute different sorts of understandings or help us understand better what sort of factors are going to make an agent more or less likable. But I personally think that a lot of the investment spent in making things really, really human-like isn't actually perhaps the best spent. It depends on what you want the robot to do. If you want it to look exactly like a human, then that's great. But if you want it to actually interact with people in a useful way and help people and have people warm to it and use it a lot over time and not get creeped out by it or not get bored of it, I don't think making something look like an exact human replica is going to be that effective.
I see. And what direction do you see robotics going in? If not completely humanoid, so what?
Yeah, so I think, again, just being a newcomer to the field of social robotics and kind of coming in from the side from human neuroscience, one of the most challenging things is a lot of the really exciting kind of human-robot interaction research, especially in the social domain, is done with a technique known as Wizard of Oz, which is where human experimenters essentially are pulling the strings of the robots to make them kind of have human-like behaviors. So they're not necessarily autonomously behaving on their own according to their programming. There's kind of a person behind the scenes telling it what to do or what to say. So I think there are autonomous robots, fewer in the social domain, but as in terms of research, but as artificial intelligence gets more and more sophisticated and we get better and better at language understanding, language processing, and kind of modeling emotions and reading and responding to emotions, I think better autonomous robots in the social domain. That's the future. And there's actually a lot of distance to cover before we'll have those.
I see. Thank you so much for your time, Professor Cross. On behalf of the entire team of the India Science Festival, we're very grateful that you could spend time with us and speak about such fascinating topics. And thank you so much for taking time out to answer questions from our audience members. I believe we don't have more time in this session, but I'm sure our audience could have heard this for hours on end.
Thank you so much. It's been an absolute pleasure. Good luck.
For our next session, we have illustrious scientist Professor Sujata Srinivasan, who is a professor of mechanical engineering at IIT Madras. Her rehabilitation, research, and device development, or very aptly named R2D2 group, focuses on development of assistive devices and aids. Thank you so much, Professor, for taking time out from your schedule and speaking to us here at the India Science Festival. We have audience members tuning in through a variety of platforms, through our other social media channels, through our outreach partners, as well as some members in the webinar. They are sending us questions that the moderator will collect and collate, and I'll ask you towards the end of the session. But till then, the floor is all yours, ma'am.
Thank you. It's an absolute pleasure to be here. And I will now share my screen, and please give me a minute. Can you see my screen?
Yes, you're all good.
And you can hear me, I hope?
Yes.
Okay, let's hope all goes well, because I have a few videos as well. So, okay, so it's an absolute pleasure to, and today I'd like to share with you. Oops. Hello, can you hear me?
Yes, we can.
Yes,
okay, Zoom suddenly said it kicked me out, so I was just wondering what happened. Okay, that's fine. So I'd like to share with you some of the work that we've been doing on innovations to enable independence for people with disability. So R2D2 stands for the TTK Center for Rehabilitation Research and Device Development. And we focus on innovations to enable mobility in our lab. So if you look at biomedical devices in general, the primary aim for most biomedical devices is to improve healthcare in some form. Some of them could be internal devices, some of them could be diagnostic devices, but essentially you're applying different types of engineering to either compensate for some kind of breakdown in the human body, or you want to enhance the capabilities of humans. So assistive devices sort of fall under the category of compensating for some kind of breakdown. It could be an amputation, it could be a spinal cord injury, for instance, that requires use of it could be post-polio syndrome, which inhibits a person's ability to walk. So these are all conditions. Or even more simply, and we don't think of this very often, but your spectacles are assistive devices. It's an assistive device because it helps me see better when my eyes aren't functioning the way they should be. So assistive devices, today we will focus, I'll talk to you about some of the assistive devices for mobility that we've been working on. Exoskeletons are also something that you may have come across news about a lot lately. These enhance the capabilities of humans, and people are working on them to, say, enhance the ability of the military, to carry loads in rough terrain, to do more, travel longer distances, etc. So it's sort of a marriage of devices and the human body, and how they can function together efficiently. So the motivation for R2D2 comes from the fact that there are over 30 million people in India alone who are affected by some kind of locomotor disability. And the World Health Organization estimates that across the world, only 1 in 10 have access to appropriate assistive devices. And so that's a sad state of affairs. Locomotor disability can be caused by a wide variety of conditions: amputations, aging, spinal cord injury, etc. And for locomotor disability, mobility can be enabled by either use of a wheelchair, or in some cases a prosthesis, which is like a replacement limb, or an orthosis, which is a supportive limb that you may have come across. So if you look at the spectrum of assistive devices, and this sort of explains why so few people have access to the devices they need, is that on one end of the spectrum you have very primitive devices, but they're very low cost. But in many cases they don't function very well, and therefore the users tend to reject the devices because it's not really very helpful to them. And at the other end of the spectrum, you have really high-tech devices, but many of them have not even made it out of the lab into the market. And therefore, their access is also very limited, or they're extremely expensive. So even in Western countries, many people cannot afford these devices. So the space that we try to work at R2D2 is to create more functional devices, but still try to keep them affordable. And I'll share with you some examples today of what we have worked on. And the typical process that we use for this development is, first you need to identify the need. So you need to interact with users. Many times the needs come from the users, and they say, we're not able to do this. Is there something that can help us to do this? So the need identification is very important, because we want to work on problems that will actually make a difference to the users. And from there, we translate those needs into design requirements. Then we do all the background research. We do a lot of, we do some conceptual design. First, we look at what is out there, what works, what doesn't work. Then we look at new concepts that we could apply to design something like that. Then work on some simulations. We do analysis. We do some prototyping, mechanical testing, and then go back to some users, see whether it's meeting the need, like a proof of concept that we test. And it's a very iterative process. So we again go back to see, okay, what design objectives, and go through that process several times. And then the outcome of the research may be patents, it may be publications. But in many cases, we wanted to at least come to a pre-commercial prototype that we could perhaps transfer the technology to a commercial partner. So, because ultimately the impact will happen only when these devices make it to the market. So that's the ultimate goal with which we work. So I'll discuss with you a few case studies on devices that we have developed. So the first thing that I'd like to present to you today is a standing wheelchair that we've developed. So the first question is, why a standing wheelchair? So you know that people who are sitting in a wheelchair all day long. I think now this is something not just for people in wheelchairs, but we've seen now because of the pandemic, most of us are spending time in the seated position all day long, attending meetings. And, the general advice is get up and walk around every, few minutes or every hour, because standing is necessary for our body. And imagine a wheelchair user who cannot stand of their own accord. So they are subject to a lot of secondary health complications. They may develop contractures where the joints sort of freeze at a particular position. They may develop pressure sores, which are life-threatening for them. And therefore, standing as therapy is actually very essential for a wheelchair user. But it's also a very difficult task for them to accomplish because they don't have the strength in their legs to come up to the standing position and to maintain that posture. So they typically need 2 or 3 people to lift them up, to put them into some kind of a device and do that. And therefore, the motivation or the ability to do that is difficult for most people. Being able to come to a standing position can also help a lot when improving the functionality of a person. They may have access to more types of jobs, they may have access to objects at different heights that they normally wouldn't be able to. It'll improve their psychological well-being and their self-esteem because they're now able to talk to people eye to eye instead of people always looking down to speak to them, etc. So the health benefits are also well established in the literature that it improves, standing improves circulation, bone health, and it reduces the incidence of secondary problems. So here is one of the early prototypes of the standing wheelchair that we developed. You can see there's a lot of analysis. I won't go into these graphs. But what we were trying to do, this is an actual user with spinal cord injury who with this device is able to self-stand, with just their arm effort. You can see he's not huffing and puffing to come up to the standing position. And all that is because of the design of it's a completely mechanical device. There are no motors, so there's no charging of batteries, etc. required in this particular device. They're using only their arm power. And so there's a lot of engineering that has gone in to kind of optimize the design to enable this motion. So this kind of shows you that, this is going from an idea to a product. So this was released last year as a product towards the end of 2019. Sorry, we are in 2021 already. So it's 2019, November was when the product was launched, called Arise Standing Wheelchair. But it started off as an idea way back, in 2010, 2011, started off as a simple class project. And it took a long time for it to become a product, and a lot of sustained effort for about 4 to 5 years with people working on it full time, going through several design iterations to come to this stage. And it also involved partnership between, Wellcome, which gave us the grant to develop this. R2D2 did the research. We had an industry partner, and then extensive interactions with the rehabilitation and user community to ensure that the design that we came up with is something that users really want. So I'll now play a short video of the standing wheelchair in action. Can you hear the computer audio?
No, ma'am, we can't hear the audio, but we can see the video.
Oh, the computer audio is not okay.
You'll have to share.
I will share the
unique wheelchair named Arise on November.
You're good now. We can hear.
This wheelchair enables persons with disabilities to shift from sitting to standing position without any external support. The wheelchair is suitable for outdoor use and on uneven terrains as well.
And a very moving moment for all of us was when at the launch, the wheelchair users were also able to stand up in their wheelchairs for the national anthem. It was very emotional for them, for many of them, because it was the first time after their injury that they were able to stand up for our national anthem. The other innovation from our lab that has now been commercialized is a device that addresses this problem of indoor and outdoor mobility. Indoor mobility, in many cases, your typical wheelchair is used for indoor mobility, but it's not really useful when you want to go outdoors. It's not designed to be used on the roads, and it's not durable enough for that. And so for outdoor mobility, people have to typically transfer into either like a tricycle or a tri-scooter, and there are risks associated with making this transfer. These are not very safe, not everybody can do it, and it's not something that can be done independently. So the solution we came up with, we have a wheelchair called the NeoFly, and we have an add-on called the NeoBolt, and I'll now play you a video that shows how this combination works. So NeoFly is like a fully customizable wheelchair. It's a very active wheelchair. It has a very small footprint. So we went back and designed a wheelchair that would not only work with the NeoBolt, but that is also better than existing wheelchairs, which sort of fall into a one-size-fits-all approach, which is not really a good way to do it. Because if all of us had eyeglasses with the same power, how useful would that be, right? So that I'll now play you the video for the NeoFly NeoBolt.
मेरा 2011 में दोस्त के कंधे पर से गिरने के कारण मेरा शरीर पैरालिसिस हो गया था। इस व्हीलचेयर प्रयोग करने के बाद आसानी से हम कहीं भी जा सकते हैं, आ सकते हैं। हम लगभग 1 साल से काम कर रहे हैं इस प्रोजेक्ट पे।
It's the best India designed wheelchair that I've sat on in 27 years.
पहले हम व्हीलचेयर से हम जो मैराथन करते थे उसमें बहुत ज़्यादा समय लगता था। इस व्हीलचेयर के प्रयोग करने के बाद टाइमिंग है वो बहुत कम हो गया। एक गाड़ी आती है जो कि इस व्हीलचेयर में आसानी से हम सेट कर सकते हैं, और गाड़ी सेट करने के बाद हम आसानी से बाहर जा सकते हैं, कम स्पेस में जा सकते हैं और कहीं भी पार्किंग कर सकते हैं, और समय का बचत हो सकता है, क्योंकि अगर हम ओनली व्हीलचेयर यूज करते हैं तो हमारी समय ज़्यादा लग सकता है। बट वो गाड़ी जब सेट करने के बाद आसानी से हम जा सकते हैं एक स्थान से दूसरे स्थान, और जो कि उसमें पूरा स्ट्रॉन्ग है, मजबूत है, गाँव में चला सकते हैं। अगर गड्ढे ऊंचे नीचे हैं तो आसानी से चला सकते हैं। अभी हमको कोई डर नहीं है, हम कहीं भी जा सकते हैं।
So this offers the seamless mobility from indoor to outdoor, and that's sort of the USP of that particular device. The third device that I'd like to tell you about is to enable a person to walk after they've had an amputation. So if they've had an amputation about the knee joint plays a very important role during walking. So you can see here, if you look at the green leg while walking, it supports the body weight. We call that the stance phase when it's supporting the body weight. So it has to support it without buckling at the knee. That's what prevents you from falling down. The muscular control about the knee prevents you from falling down when you're supporting weight on the knee. And then during the swing phase, the knee bends and then clears the ground to prepare for the next step and move forward. So the knee has to be very flexible to, allow you to both load it without it buckling, as well as bend when it needs so that you can clear the ground during the swing phase. Now, this kind of control is very hard to achieve when there is when there are no muscles around and when the knee joint is missing. So in an external device, so the easiest thing to do, especially when a person has to walk on uneven terrain, is to just lock the knee. So if you lock the knee, then you ensure that they will not fall down. But what happens is when they have to now clear the ground, you may have seen people walking, from their hip. they kind of make this rotational motion. It's called circumduction to clear the ground. And that's a very energy intensive kind of manner of walking, and takes up a lot of energy. And many people, get tired. They may not use their prosthesis very much and decide to use a wheelchair instead. But, wheelchair use comes, and if there is a possibility that you can make a person walk, then that's something that we should consider. So there are different kinds of prosthetic knees. You have what are known as single axis knees, and then you have what are known as polycentric knees, where you have a moving knee center. And polycentric knees have been shown to have better characteristics. They allow the user more control of the knee while walking, even with their residual limb, the musculature that's there in their residual limb. And therefore, but we don't have any polycentric knee that has been designed in India, and that is specific to Indian needs. The main thing with a lot of the devices that we design for India is it's the rough terrain. Being able to handle the rough terrain, whether you're walking or moving in a wheelchair, is a big task. So what we did was, there are multiple knees that have different types of geometries in the 4-bar knees. So the first thing we did was we analyzed all these different knees, and we sort of defined parameters that would help us determine what would be, what are these parameters that have to be satisfied in order for the knee to work well on uneven terrain. We found that none of the existing knees really met that objective. And therefore, the red one that you see, so if you look at the best knee, would probably be the one that would be this hexagon for the parameters that we defined. But none of them, are meeting all the requirements. So we came up with the knee in red is what we found by optimization, which sort of tries to meet all these requirements as best possible. Because many of these are competing requirements. That's why it's a hard problem to solve. And then we came up with what we call the IATM polycentric knee. And this knee has certain unique features. It's made of, it's very stable on uneven terrain. About 20 users. Our testing partner is Mobility India, and about 20 users have used it for a couple years now. And it's a simple knee, it's functional, and we expect to make it affordable. We've transferred the technology to our partner, and you can see here, I'll play you a video of this knee in action. So it can handle steps, it can handle, and it's simpler than many of the knees that are currently available. It's also made of high-grade material. Most knees that focus on being low cost sort of use, inexpensive materials, but many of those materials may not be durable enough for long-term use. And therefore, we came up with something that not only has better geometry, you can see how confidently this person is walking up and down a ramp, which is quite a difficult task to do, because maintaining the stability of the knee is a difficult task to do. Negotiating steps is another, and also our lifestyles. We want to sit in cramped spaces, for instance, like in an auto. So this knee provides more knee flexion than in many of the knees that are commercially available. Again, this was a collaborative effort. It was funded by the Defense R&D organization. Mobility India was our testing partner, user testing partner, and they have also now taken over the technology, and they will be commercializing it hopefully later this year. So these are the 3 devices that I wanted to share with you that we have developed. And really the ecosystem that we have created is we want to innovate and make for India and eventually the world. But first, meet our Indian needs especially. And R2D2 has a unique R&D environment. We have biomechanical facilities. Being in an academic institution, we follow a rigorous scientific approach to this development. And we also have the ability to get support through grants from various funding agencies for this development. And that is one of the things that keeps these devices affordable, because all the R&D costs are taken care of by the funding agency and the facilities that we have in our lab at IIT Madras. And we hope that more people will start seeing assistive technologies as a career option, and start working on startups in this area, because the need is huge. And going from prototype product to market is a long journey, but it's something that needs to be done in order to make an impact. We've also developed various test rigs, so we can test the wheelchairs to ISO standards. Sorry. Sorry about that. So we can test the wheelchairs to ISO standards, as well as prosthetic devices, etc. We've developed prototyping facilities as well as testing facilities, so that we want to develop high quality devices. We want users in India to have access to high quality functional devices at affordable prices. But we also know that an appropriate assistive device has to meet certain requirements. So one, it has to be functional, of course, but it also needs to be affordable, as I emphasized earlier, for people to be able to make use of it. Then awareness creation, because most people don't know what is available. So awareness creation also becomes an important aspect of making sure that these people have the information to ask for the appropriate assistive device. Then access, being a diverse, how do you ensure that these devices are easy to obtain, easy to maintain, easy to service? So we have to create models for all these. So there's innovation required, not just in creating an assistive device, but in all these surrounding issues as well. The affordability, for instance, we use this collaborative model for development, as I mentioned earlier. And then we, ultimately, we want the devices to be accepted, because when the user finds that it's functional and it is something that they are proud to use, they're more likely to use it. And there's going to be less of a stigma attached to it. I mean, why not, right? I mean, eyeglasses are now a style statement in many ways, even though they are an assistive device. So why should that not be the case with any assistive device that we choose to use or that we need to use? So that is what we want to do at R2D2, to develop these kinds of devices that will enable independence for their users. Of course, all this would not be possible without the partnerships that we have and the support that we have received from various sources. We work with a lot of NGOs, user groups, we work with hospitals, we work with academic institutions, we work with industry, who we need to translate these products, and we've received support from various sources that has enabled us to do this research. Over the last 12 years, these are some of the devices that have at least come to a prototype stage. These are wheeled mobility solutions. We have some pediatric solutions in the works, prosthetics and orthotics. I showed you an example. They're working on devices for rehabilitation and therapy as well. And we hope to translate as many of these as possible to the market, or somehow reach it to the users through other models as well. So that kind of concludes my presentation. But our goal really is not to, it's to design in India and make for the world. And we hope we are able to do this. I hope this talk inspires some of you to start exploring problems in this area. If you'd like more information about our work, please visit our webpage. You'll find some videos there. R2D2 also has a YouTube channel where we post videos of some of our devices. And I want to thank you for this opportunity. And if we have some time, I'm happy to answer some questions.
Thank you so much, ma'am, for a fascinating talk. It was truly a pleasure getting a sneak peek into the inner workings of R2D2 and how exactly you are doing this fantastic job trying to meet a need that is perhaps not very well known. We do have some questions from audience members through various channels. If you can stop sharing your screen so that our audience can actually...
I'll do that.
And thank you so much for talking to us about such a fantastic issue. The videos that you showed us truly were emotional, and I can imagine how the actual sessions might have been. Based on that, one of the questions that we are getting from our audience is that what exactly inspired you to use mechanical engineering for such a good cause?
Okay. My journey in this field actually started in my undergraduate days at IIT Madras. So I was, on the cusp of becoming a full mechanical engineer. So in my final year, we had to do a project. And I wanted to do something where I could see some tangible benefits to people. And so I started, talking to different professors to see if any of them had some such project. And one of the professors, he had a project with CMC Vellore, the hospital where they do a lot of the rehabilitation. And that is when, I visited CMC a few times. I worked with some of the doctors there, and I was just hooked because just the thought that I could actually use my knowledge to make a difference in people. And since then I went to the US. I spent 15 years in the US. I did my master's, but that was again in this field. And then I worked in industry, designing prosthetics. So it's like, I was just lucky that opportunities opened up for me every day. Maybe because I was just, singularly focused on this field. And then I came back to India in 2008, back to IIT Madras, this time as faculty. And I thought, things really hadn't changed all that much in this field from the time that I left to when I came back. And so I thought, why not continue the work with my students? And I've been fortunate to have extremely good students, very motivated students who've helped me continue this work and make R2D2 what it is today.
That's a interesting and very inspirational journey. I'm sure some of our audience members will take important messages away from that. Throughout the course of your talk, you always mentioned creating affordable devices for the world, but in India. And some of our audience members would like to know what is the cost-quality trade-off for the kind of products that R2D2 is making?
We are trying to make it so there is no quality trade-off. There is no quality trade-off. So we test these products we test these devices to ISO standards. Okay, so the certification, all that the companies have to pursue. But in the internal testing that we do, we look at the ISO standards. We've developed the test rigs to test to those standards, because I don't think we should be compromising quality for the cost. The affordability comes from various things. One, in our approach, we are looking at making these devices customizable while still being mass manufacturable. I'll give you an example. In the case of the standing wheelchair, in some of the products in America, for instance, we tried to get one for benchmarking. And that product, they said, tell us where the user is. We'll come, take their measurements, and build you the device for that person. We've taken a different approach. We've incorporated a lot of adjustments within the design through extensive testing, so that it can be fine-tuned. Similarly, even with the NeoFly wheelchair, you can get a fully customizable wheelchair, but it's a mass manufactured product. So that you bring in the cost savings from manufacturing, as well as the cost savings from R&D, because we are doing the R&D in an academic institution. We are getting in grants to do the R&D. So the company doesn't have to worry about the R&D costs. So, all these things, it takes a lot of money and resources to develop these, because it's like a 4-year development time when you want to develop it to high quality. So we do not want to compromise. These products in quality should be comparable to anything that is available in the world. That's our goal.
Oh, that is fascinating and comforting to hear. And another aspect that you sort of focused on in your talk was maintenance. Like once the product has been taken to market and is being used, I presume that it does require some maintenance. And that is also being done with the same mass-produced but customized approach.
Yes. So I'll share with you an example that our startup NeoMotion is following for maintenance. So they always ship every wheelchair and the NeoFly and NeoBolt with a set of tools. So all these, while designing itself, we make sure that the designs are simple enough. The standing wheelchair, for instance, can be serviced at a cycle shop, at a nearby cycle shop, if you need some kind of maintenance. The NeoFly, for instance, they ship them out with a set of tools. So if the person needs to make some changes, they have videos available, or they get on a video call with the person and help them go through the process. So it's, the user or somebody close to them can do that. So we have to come up with innovative methods of doing this, because it's not possible for a startup, for instance, to have people all over India, for instance, servicing these. And it's not reasonable to expect a person to ship the wheelchair back every time something goes wrong. So we have to come up with creative ways, and this is one of the ways they are doing it. And I think COVID kind of accelerated that process, because the NeoFly wheelchair, it's completely customized. So when it lands at the user's doorstep, they go through a process of interview and questionnaires and measurements, and all that is done back and forth digitally. And then a fully customized wheelchair lands at their doorstep, that fits perfectly. So it's sort of the analogy between, tailored versus ready-made clothes, where, so that's the analogy I like to use. So customization, you can either tailor something which increases the cost significantly, or you customize it and deliver something that's pretty close to what you need. And then if you need to do some fine tuning, that can be done even remotely if necessary.
I see. And following along the same lines, do you anticipate challenges in actually scaling these commercially to meet all of India's needs? I believe in the very early part of your talk, you mentioned that we have more than 10 million potential users for these devices.
Yes, that is a challenge. So there is a need. We have to create the demand as well, because the need is there, but that's where the awareness creation also comes in, because many people don't demand, they don't tell the government, look, don't keep giving us these depot style wheelchairs. They're not useful to us. So people with disability need to start demanding better devices. And then that will create the market for these companies to become sustainable. And then, of course, there are challenges, because hardware startups in India are very difficult to run, as we have learned. Funding is hard to come by. Just running it is a very difficult task. If it's an existing industry, that's one way of doing it, because they already have the infrastructure, and they may have the the ability to scale up more easily. But on the other hand, the startups are more agile. They are more passionate because this may be the main thing that they are doing. So you have your pros and cons everywhere. But yes, scaling is, but I think if the demand is created, then I think the companies will be able to invest and scale up as necessary. But making them sustainable is a challenge, and that's where NGOs, if they are able to either get more grants to supply these devices to people start demanding them. I think that awareness creation is very important, and that's also something that we are working very closely with the different NGOs and hospitals and rehabilitation centers to increase awareness about these devices. So the greater the demand, then the more sustainable the business will become.
I see.
Scaling up will become easier.
Because that's a question that we got from the audience also, that this is a fantastic initiative that perhaps many people know about, and what can be done to increase awareness and demand for such.
Yes. So awareness creation is something also that we are working on. We want people to demand good devices.
I have one more question from the audience, where you mentioned that there is still some sort of stigma attached to perhaps assisted devices, and they haven't reached the same normalcy level of, say, glasses yet. And what is your opinion on how that stigma can be removed? Is it an aesthetic challenge to meet, or is it something else? And how can we as a society tackle it?
Yeah. So it's on multiple fronts. Aesthetics is definitely a very important aspect of it. You don't want devices that look bad. So one of the things that we do is we work with industrial designers with our designs to make sure that aesthetically they are pleasing. It should be something that nobody is ashamed of using a bicycle or a two-wheeler, right? In a sense, they help you do what you need to do better. They help you traverse longer distance. So why should a wheelchair be any different, right? So, but that's where, one of the problems is because many of the devices are not appropriate, you don't see a lot of wheelchair users, for instance, in and around you. So the awareness that the problem even exists is very low. Most people are confined to their homes and don't have the means. If you look at the infrastructure around, many places are not accessible. We are not a very friendly society when it comes to people with disability, and that needs to change. And so these devices, aesthetics is one thing, functionality is another. So when you provide the functionality and people say, hey, my life is a lot better when I use this device than when I don't, then they start doing more things. They become more independent. You start seeing them around more, and you say, oh, maybe this is not something that needs to be a stigma after all. So we need role models among them that are not afraid to, go out and do things. And we have several of them. It's just that we don't hear about them that often. When you work in the field, you come across them every day. You see people who are doing fantastic things. And that's something else we want to do. We want to showcase more of these users, inspire people and tell them, what they can do rather than what they cannot do when they encounter an impairment. Because it could happen to any of us, really. So, and that's something I think people need to remember. It could happen to any of us. And therefore, why treat someone differently just because they have to use an assistive device? And now with life expectancy is increasing, almost all of us are going to need such assistive devices to function independently. So I think slowly the attitudes towards these devices will change, but aesthetics also form a very big part of that. That's something we are very particular about.
Well, I hope we as a society can gradually move towards being a more friendlier, more inclusive society. For my last question to you, ma'am, I just want to get a little bit of your opinion about platforms like India Science Fest in communicating science to society, or perhaps your experience with this.
Oh, I think it's been fantastic. I think it's a fantastic idea. I hope you have had a lot of people watching these talks. I think the previous talk I joined in and it was fascinating. So it's wonderful that you're bringing together so many different areas, so many people talking about so many different fascinating areas. And I hope youngsters especially are watching this, because you guys are the future, and if you start working in some of these areas, we can see fantastic things happen. It's been very professionally organized. I mean, I'm very impressed with how well you have organized this festival, and kudos to you. Great job.
On behalf of the entire team of India Science Fest, I would like to thank you for taking time out of your schedule. And we are very grateful that we could spend some time with you, get insights into what a fantastic job R2D2 is doing, and also learn more about issues that perhaps have not yet gotten the true recognition that they deserve.
Thank you so much.
Thank you so much, ma'am, for
Thank
speaking
you.
with us. It's been a true pleasure.
Likewise, and all the best. All the best.
For our next session during the India Science Festival, we have been running a small series of competitions called Talk Your Thesis. And we have a Talk Your Thesis finalist, Arjun Kamdar, with us. Arjun, can you please switch on your screen?
Yes. Hi.
Hi, welcome to India Science Fest. Looking forward to hearing details of your thesis. And we have 15 minutes for your presentation, following which we have a panel discussion on healthcare research in India. That's moderated by science journalist Kavya Narayanan. The floor is yours, Arjun.
Thank you. I'll just share my screen.
Yeah,
And
go ahead.
I have poor internet, so I'll just stop my video also. I'll just share my screen though. All right.
Okay, you're good.
Yes. So hello everyone, thanks for being here. I will be presenting my thesis that was carried out in the Brahmaputra landscape of Northeast India as part of my MSc in Wildlife Biology and Conservation at the National Center for Biological Sciences, Bengaluru. So each year, 500 people and over 100 elephants die due to negative interactions between the two species in the country, that's people and elephants. And this number has been steadily increasing. This is suggested to partly be due to large-scale habitat change and deforestation. This time-lapse indicative representation of elephant ranges across the country. This is from my field site in Assam. And in addition to these deaths, these negative interactions also lead to the deterioration of the quality of life for both the species. Several thousand families across the landscape are under the constant fear of losing their life and property to elephants, often leading to severe psychological trauma and diminished well-being, as has been noticed in a bunch of studies. Now, given the consequences of these conflicts, it is imperative to aid the two species to share spaces safely from both a wildlife conservation perspective as well as a social justice perspective. And in order to do so, a host of methods are employed. However, the most widely used is the non-lethal power fence, which gives the elephant a shock but does not kill it. And this is done in order to keep them away from human habitation and thus keep both people and humans safe from each other. In order for these fences to work, that is, carry a voltage high enough to deter elephants, it needs to be well maintained. That is, people need to work together collectively in order to ensure that the fences work. Now, this is exactly like a public good, where the people who are beneficiaries to a system have to come together and agree on a set of norms, a set of rules in order to reap the benefit of the good. And that's essentially what happens here as well. These fences are set up with the help of the government or NGOs, given their high capital and technical requirements, and then given to communities who are entrusted with its maintenance, which involves cleaning the undergrowth and checking on technical equipment like the solar panel and battery as noted in the diagram here. However, despite the perceived effectiveness, with people suggesting it to be between 80 to 95% effective in deterring elephants, only about 35% of the fences in the landscape are well maintained and functional. Now, this throws up a very counterintuitive question, because here we have a problem and a technical solution, yet somehow the social and governance systems are not allowing the solution to be functional and remedy the problem. Therefore, I asked, why are some fences well maintained while others are poorly maintained? And while many have studied the effectiveness of different deterrents, very few have looked at why they fail. And this project particularly interested me because it is at the intersection of ecology, economics, and sociology with a very applied perspective as well. And the Sonitpur district in the northeastern state of Assam proved to be an ideal study system to answer this question, as there was enough variation to make comparisons and identify links on how different factors, both ecological, such as elephant behavior, and sociological, such as the entities involved in monitoring systems, played a role in maintenance. So I studied 19 villages with fences in the region, and these were spread across tea estates, forest fringes, agricultural areas, and industrial areas. So the study had two objectives. The first one was to gauge whether a fence is well maintained or not, for which I created an index, which was then subject to a blind and non-blind assessment by experts. The second objective was to identify what caused the maintenance of fences. This, of course, included the ecological factors like the elephant raiding patterns, and sociological ones like governance systems, goodwill, social sanctions, level of trust in the community, and other such variables, and how they interact with one another to result in an outcome. So I designed the study using Ostrom's framework, which is used to identify potential variables of interest in such systems like public goods and common pool resources. And this was complemented by grounded theory, which is where the researcher uses data to build hypotheses, which are then further tested against more and more data in an iterative process. And this is coupled with inductive and axial coding. I will explain this in the coming slides with an example so that it's clearer. And finally, a qualitative comparative analysis was used to further verify and corroborate the results. And I used a host of sociological tools as well, as mentioned here, and we'll see in the coming slides, which included semi-structured social surveys, documentary materials, participant observations, informal conversations, camera traps. So essentially, I used everything that I could find as data to answer this broader question. And that yielded a huge data set at the end of the thesis. And I'll just give an example of how I went about doing this. Here's a graphical representation. So I used all these several methods to triangulate and verify certain things. For instance, in this village, we found that the fence was serving as an interference to the livelihood of people, and therefore it was not being well maintained. And it was found corroborated through these three different methods. And then that variable was found to be relevant and was used to build an overarching theory, which helped explain our outcome. And of course, it could, here it was livelihood interference, but it could mean any variable of interest. And all of these variables of interest were linked together using something called axial coding to build this larger theory. The results showed that there were three potential pathways that led to maintenance, and the qualitative comparative analysis further verified our result. Now, this uses a holistic perspective incorporating set theory and Boolean algebra to aid understanding of these links. In the interest of time, I shall present only the results here, and we can take this up in the questions if people have any doubts regarding the methodology. So again, here also we found that for it to be, for a fence to be well maintained, there has to be a community maintainer who is accountable, or the community has to manage the fence themselves, but they should also have technical ability to do this, or the forest department entirely undertakes maintenance. And that then leads to a well-maintained fence. Now again, here is the graphical representation of the three different pathways, and I'll jump into them and show these different perceived costs and benefits, as here B greater than C refers to the perceived benefits being greater than the perceived costs for that entity. So for the first pathway, the community maintainer, which refers to an individual hired by an external entity or the community themselves. So for them here, in addition to the material payments in the form of cash and a part of the crop produce, the goodwill earned was also found to be a very strong determinant. For the second pathway, refers to when the community self-organizes and actively maintains the fence themselves, such as by setting the responsibilities on the roster basis. For example, this household will do it on this day and this household on the next, so on. Here, the strongest benefits were the peace of mind and the property saved, such as the crops saved and the less likelihood of damage to one's house, etc. However, fences in such circumstances also were found to fail due to the succor phenomenon, which is when one faction of the community refused to participate in activities because they felt that somebody else would anyway maintain the fence. Now, this led to others feeling that they were getting a raw deal by them undertaking efforts that all individuals benefit from. Therefore, all the members stopped undertaking efforts altogether and the fence failed. The final pathway is when the forest department maintains the fence. They were found to do this when they have external pressure from officers higher up in the hierarchy or a personal incentive, such as an opportunity to make some money. And another very interesting factor is when the elephants were found to do the forest department's job of enforcement for them. For example, the forest department maintained the fence in these regions to restrict elephants to a particular area and not allow them to cross into human-dominated areas. This is because the mere presence of the elephants in the forests greatly reduced the activity of the illegal loggers, tree loggers, and trespassers, thus reducing the need for patrolling the area by the forest department and therefore reducing their workload. So in some sense, they got the elephants to do their work for them. Now, this is a very interesting socio-ecological system and is influenced by both human behavior and elephant behavior interacting with one another. For example, such as here, where poor maintenance of fences led to more breaches by elephants, which led to a lesser perceived benefit in the mind of the community, which fed back into poor maintenance, creating a vicious cycle, a feedback loop of non-maintenance. And then this would just proliferate. And conversely, we found this true for well-maintained fences also. Well-maintained fences, lesser breaches, greater perceived benefit, better maintenance. And interestingly, we also found circumstantial evidence in certain places where elephants avoided a place where there had been a functional fence before, irrespective of the current status of the fence. And in cases, even where there had been fence-like objects at all, somebody just putting a wire joined by two bamboos, and suggested by the respondents to be due to past negative experiences by the elephants. That is, they must have been shocked by a fence that looked very similar to that, and therefore they avoided all fences altogether. And thus, even poorly maintained fences that are not live and don't carry any current could deter elephants in some cases. However, I was not able to empirically test this in my study. And even if both these phenomena were true, it does not really change the intervention. Because for both of these things to work, there have to be some amount of functional fences in the landscape. And there are a few implications and recommendations for conservation interventionists here and practitioners. One is to preemptively identify which pathway is most likely to function. And in some cases, for example, in some cases where elephant raids are very infrequent and predictable, and where people are anyway relying on other mitigation measures like shouting and firecrackers, fences will not be of importance. Another would be to attempt to involve all the households during the establishment of the fence by engaging with them. Whether they participate or not is immaterial, because a shared context is created, and this reduces the chances of the succor phenomenon playing itself out. And finally, where we find evidence of a social ecological trap, an external entity like an NGO or the forest department can increase maintenance to highlight the perceived effectiveness and then hence break the vicious cycle. And just to conclude, I think that improving the lives of both elephants and people is possible, and coexistence of both these incredibly intelligent mammals is possible in this landscape. So just to tie everything together, I found that there are three pathways to maintenance that are shaped by a host of perceived benefits and costs. And we can now shape these systems such that they are more likely to result in maintenance and hence be more effective. With hundreds of kilometers of fences cumulatively costing millions of rupees, it's very important to ensure that they serve the utility that they are designed for. The findings are also relevant for similar interventions that rely on both social and ecological variables in order to be functional. And additionally, at a more broader level, I think this study highlights that we cannot simply have technical solutions to problems that are deeply entrenched in such socio-ecological systems. That is, a prescriptive solution without a descriptive understanding will not work. And for this, the understanding of the context is critical, and it should be congruent with those on ground zero. Like, for instance, here we found that in addition to material benefits, social benefits and social standing was found to be so important. And I found that qualitative social science data helps, and studies like these help bridge the gap to build better solutions, especially in such highly complex and chaotic systems. Thank you. I'd like to thank a bunch of people who made this work possible: the National Center for Biological Sciences, WWF, WCS, CWS, the Department of Atomic Energy for funding this, the India Science Festival, of course, for this wonderful platform, and a whole bunch of other people, including my advisors, Dr. David, Dr. Nagendra, Dr. Besha, Dr. Ratnam, and Dr. Sekar. Thank you.
Thank you so much for sharing a fascinating talk with us, Arjun. It was an amazing study, and it was really nice to see how a lot of interdisciplinary aspects feature into it. Thank you so much for joining us at ISF.
Thank you.
We've had a very exciting lineup of events so far, ranging from robotics to now ecology. And I think now it's time that we venture a little bit into healthcare. We have a very exciting panel on healthcare research in India for Indians that's being moderated by Kavya Narayanan, a senior writer and journalist at First Post. I'm going to hand over the dais to Kavya so that she can introduce the panel and take it away from here. I request the panelists and Kavya to please switch on their videos.
Hi. Hello, everyone.
Hello.
Kavya, you're muted.
Hello. Can everyone hear me?
Yes, you're back now.
Okay. Just give me a second.
I'd like to welcome all of you to our panel. On behalf of Team ISF, we are very grateful that you could take time out from your busy schedules to actually be with us and talk to us about a very pressing issue in modern times. Over to Kavya now.
Yes. Thank you so much. Hello, everyone. I'm Kavya Narayanan, and I'm really happy to be here. We're going to talk about something really interesting today. It's about healthcare, and this is an especially interesting year to be talking about healthcare. And we have some really interesting people joining us today for this conversation. So let's start with a round of introductions. So starting with Professor K. Srinath Reddy. He's the president of the Public Health Foundation of India. He is formerly also headed the Department of Cardiology at the AIIMS Center. And under his leadership, PHFI has enabled 5 Indian institutes, IIPHS, for public health, in different regions of India to advance multidisciplinary public health education, research, health technologies, and implementation support for strengthening these health systems. So he also holds advisory positions in many national and international bodies. And he's recently published a book called Make Health in India, Reaching a Billion Plus. So we're really happy to have you here, Professor Srinath. Thank you so much.
Pleasure. Thank you.
We also have joining us K. Sujata Rao. She's the former Union Secretary at the Ministry of Health and Family Welfare at the Government of India. She was involved in the first ever national program for non-communicable diseases, the process for a national policy for the use of antibiotics, and introducing vaccines in public health. Previously, she was also Director General of the National AIDS Control Organization between 2006 and 2009, where she was instrumental in enabling systems and building up NACO with the capacity to implement programs with a 5-fold budget increase. She's also represented India on boards of the WHO, the Global Fund, and UNAIDS. Thank you so much, Sujata, for joining us for this conversation as well. Really happy to have you here. We also have joining us Dr. Vidur Mahajan, who's the head of research at Caring, CARING, Associate Director also at Mahajan Imaging. He handles everything at Caring, from the operations to the commercialization strategy for products developed at Caring. Caring is an organization that's built the world's first end-to-end validation and deployment platform for medical imaging AI. He also runs Caring DX, which is the most advanced molecular diagnostic labs in North America, and it focuses on genome sequencing and
I wish it was North America, or maybe not.
Not India. Not India. I'm sorry, North America, not India.
No problem.
Yeah, thank you so much for joining us today.
Thank you for having me. Thank you to the ISF team. It's indeed an honor to be part of, like 3 of my heroes on the same screen. So it's amazing. Thank you so much.
Lastly, our fourth panelist is also here, Dr. Ramesh Hariharan. He's the co-founder and CEO at Strand Life Sciences. He's also an adjunct professor at the Computer Science Department of the Indian Institute of Science, Bangalore. Dr. Ramesh and his team at Strand have been working on technology to make DNA sequencing for genetic disease diagnosis affordable in India. Dr. Ramesh is a recipient of the TR100 Award of Young Innovators by MIT's Tech Review magazine. And in 2003, he received the Global Indus Technovator Award from MIT. Congratulations, Ramesh. And he was also recognized among the top 20 Indian technology innovators worldwide. Really happy to have all of you.
Thank you so much.
Okay. So let's start off with the questions right away. I think the first one, I would really like Sujata to start this conversation with this. So we've been hearing a lot of talk of late about healthcare systems falling short and being inadequate to actually meet this pandemic that we're in the middle of, to meet it head on. So considering, COVID, SARS-CoV-2, the virus is a novel virus, and the next one could also be something as novel and something that we don't know about. How can our health systems actually prepare for an unknown, an unknown variable like this? How does one actually prepare for this? Can you give us a little bit of information on that?
Thank you, Kavya, for having me here. And that's a great question because it's so relevant. And, we must be very, very aware that this is not the last that we have heard of this kind of a virus. Please do expect many more to emerge and could even be worse than what we have faced right now. So the virus is not a calling card on us, and to say that you better get your act together and change your health system accordingly. Now, what really needs to be done, in my view, is that for India to get prepared for any such contingency, we need to focus on primary health care in a very serious manner, not just question of having a health and wellness clinic, but much, much more, and build the public health capacity in a very integrated manner. That means a multi-pronged strategy. We need to change our medical education system to train our doctors on public health. Public health means, I don't mean health delivered in public institutions, government-owned. I mean public health in terms of the classical discipline of involving epidemiology and biostatistics and so on. So I think we need to have a full-fledged, trained, well-trained cadre of public health who can do a very good disease surveillance setup and data management, systems be put in place in our country along with primary care. So it means changing your education system. It means providing enough incentive structures so that all doctors who are studying medicine don't want to be specialists and neurologists, but would like to be in public health and go and work in primary care centers. That can happen if you improve their work conditions, give them the social respect that they deserve, and also give them the recognition that they're due with good salaries. Today, what Dr. Trehan earns as a clinician and what a public health doctor, epidemiologist earns in a rural area is so vast that nobody wants to be a public health care. So that needs to be changed. And I think overall, health budgets have to increase and be very, very focused on building our public health capacity of so that such diseases are taken by the surprise that they have this time. You know, we've come off easy, I would say. We may not be so lucky next time.
Yeah, and I would also love to hear from Dr. Ramesh on what he thinks, you know, the private players in India can contribute to this effort, because it does sound like a really, you know, long term, and we have to build step by step. But even in today, in terms of diagnostics, I think we've seen so many incredible efforts all over India to like scale up. And how can the private players be a key contributor to this preparedness for pandemics?
Right. So, I mean, the biggest thing that this pandemic has done, it's opened our eyes and minds to questioning all the assumptions that we've been taking so far. Right? And we've all talked about how do we really need offices? I mean, do we really need to be commuting so much? Do we really need to be waiting an hour at the doctor's office to see the doctor? So, I mean, there are just so many of these assumptions that we can, you know, we are questioning today. And I mean, we didn't have to wait for the pandemic. I mean, this was common sense, but human beings and societies have inertia, and this has opened our eyes really to start thinking afresh. And when you start thinking afresh, I mean, there are just so many things to be done, right? I mean, if you just take, you know, the simple premise, how do we ensure that we don't have to be shipping people around? So immediately that leads to telemedicine, and you know that's taking off regardless of whether you do something about it or not. Just given
the pace of technology.
Yeah, and so the with telemedicine comes, of course, a lot of participation for the private sector, because I mean you need tools, you need protocols, you need language capabilities, you need payment systems, incentivization systems. I mean, just the whole works that I think the whole private sector has to play a bigger and bigger role in. There are many other areas where, I mean, the question is why wait for the next pandemic? Obviously, there's a question that's, and the pandemic may or may not, the next one hopefully is far away, but we have enough pressing problems that we can learn from this pandemic and implement. So why can't the pace be pushed? We did a vaccine in 6 months, 8 months, unheard of. Why can't we get into that mode for everything in life? I mean, why do proposals take 6 months to a year to review? Why shouldn't deliveries be expected in 3 months when today they take 3 years? If that mindset comes in, then everybody, I mean, private sector, public sector, whoever, because the pace just gets, there are changes means there are new things to be done, and second, the pace gets picked. And once that happens, I think, I mean, there's no question that the private sector, the public sector, every individual will have more than plenty to do. Yeah, right. So that's how I would look at this whole, from a very fundamental perspective.
Yeah. And Professor Srinath, I want to go to you next to hear from you about this concept that we've been hearing a lot about of late, which is universal healthcare. It sounds like this dreamy thing where, everybody gets access to affordable, quality healthcare. And it's not a joke here, because we really do need all of those things. There's no one place probably that has all three: affordable, quality healthcare that's available for everyone. So is this universal health coverage a kind of format that might work in India? Can you tell us a little bit about, what are do we need this as well? Because a lot of countries have taken up universal health coverage as a priority and are working towards that. Are we also one of those nations? And yeah, essentially that.
Well, it's very clear that there is a need. And if you look at India, after 73 years of independence, there are many sections of our population who are facing serious barriers in terms of access, affordability, and even quality of healthcare. And therefore, we do need a universal health coverage system which can address many of these challenges. And we are committed to it even as a part of our National Health Policy of 2017, as well as the Sustainable Development Goals of the United Nations to deliver on it. But obviously, this requires much greater degree of public financing because we are right now heavily under-resourced in multiple aspects in terms of financial resources, human resources in the health system, as well as in terms of inadequate infrastructure in various places. There are multiple barriers that need to be corrected. So in public financing needs to be definitely increased to 2.5% to 3% of the GDP as soon as possible. And we need to merge all our financing schemes, whether central, state, even employer-provided insurance, and preferably even private insurance, into a single payer system, which gives a large risk pool and offers a much larger package of services. We need to strengthen primary healthcare systems in both rural and urban areas, because that is the fundamental base and edifice of a good universal health coverage system, with, of course, good connectivity to higher levels of care with strengthened district and medical college hospitals. We need an increased health workforce, which is multi-layered and multi-skilled. And certainly, even as we are trying to build up our numbers and skills, we can actually bridge some of this by adequate and appropriate use of technology in terms of providing a greater degree of equity in terms of access and also improving the quality of services. We need to actually bring in the public sector also to participate along with a much strengthened public sector, but the private sector needs to come in as a contracted provider on the terms in the format set by the public sector. Therefore, it has to partner in the universal health coverage and not act as an independent autonomous competitor. Then we need to provide drugs and diagnostics, the essential drugs and diagnostics, free of cost at public facilities at least, because that is one major source of out-of-pocket expenditure, which is very debilitating. We still have about 60% out-of-pocket expenditure in terms of healthcare. Then we also need much greater degree of community engagement, a much greater participation of the community in the design, delivery, and monitoring of health services. And we also need fairly robust healthcare systems, but also we need robust regulatory systems in multiple areas, right from the quality of care to education and in quality of drugs. Everywhere we need to strengthen our regulatory systems. And of course, we also need allocative and utilization efficiencies of the money with a strong focus, as I said, on primary health care. So we need more money for health, but we also need more health for the money. We need to spend it well too. And that's where primary health care comes in very strongly.
Yeah, absolutely. And you had mentioned that the healthcare ecosystem in India is under-resourced. Is there anything you can say about what aspects of healthcare really need the most resources right now? Is it in terms of manpower? Is it finances? Like, what are the most crunched resources?
Well, you can't really build up a large health workforce without increased financial resources. Yeah. And also improve your infrastructure as well, and ensure that you have adequate drug supply. So financing is required, but you also need to utilize those finances in the right place with the right priorities. And there is a specious argument that is often advanced that many states are not spending the money already allocated, so what's the point of giving them? But that is because an inadequately functioning health system does not have the absorption and utilization capacity. So you need a lot of front-end spending to strengthen the health system so that you can utilize the increased financing much better. Therefore, it's a question of ensuring that you give more money, but make sure it goes to the right place and with the right kind of priorities.
I think Sujata, you wanted to add something? Yes, Sujata, you wanted to add something.
Okay. No, in addition to what Dr. Reddy said, if you really look at the universal health coverage as what does it mean as a concept, is ultimately the key objective is that all our people, 1.3 billion people, should be healthy. And I think, it's not, health is not a question of only doctors, hospitals, and beds and technology. It is clean air. It is about everyone getting access to tap water. It is that everyone's behavior is towards eating healthy food and not junk food. Everyone takes walks and everyone goes to toilets and has enough exercise. Now, these social determinants are not being seriously looked at by our government. When we talk about health, we tend to only think in terms of doctors, which are very, very important, and drugs and diagnostics. But I think adequate investments must be made. I mean, it's great that this government has given such a priority to toilets and is now shifting priority to tap water, which is what Rajiv Gandhi had dreamt of way back in 1985. But if you see every country that has done well on health indicators, they first resolved this issue of access to social determinants. And can you just imagine if we had clean air in Delhi, we'd be saving how many lives, that we lose every year on account of contaminated air pollution. So I think along with this, if we can go deep dive and enforce our laws against, say, consumption of tobacco, consumption of alcohol, and so on, we really bring down our disease burden by half, if not more, and reduce our need for hospitals and specialists thereby. So that's also part of the UHC package.
Thank you for that. That was a very interesting example and something I think a lot of us can relate to. Health is, not just for doctors and drugs, but it's up to all of us as well a little bit to watch ourselves. Dr. Betur, I wanted to hear from you about something that I think is important in the healthcare research side for sure. As and when we're moving along, we're getting access to new technology that's using a lot of data. And we're seeing in a lot of countries that data is being used very well to understand the needs of the population in terms of healthcare, very specifically. So only now have we in India, we've seen, online records being maintained, and slowly we're starting to move to a more online ecosystem, but we're not quite there yet. How important is it for local data and research to be gathered? And how can it benefit a population like India's? Can you get into that a little bit?
Sure. No, and thanks for that question. And it's something that we think about a lot at our organization. See, the fundamental thing about, and this is a data digitization almost aspiration that almost everyone has. Any healthcare data analytics person cannot get their head around the fact that healthcare data is not digitized, because it's so important. We can get so many insights, we can do so many cool things, right? The fundamental issue is that there is no incentive today, not only for storage, but also for use of the data. But use, one can still figure out. There are a lot of ways you can save cost, you can drive efficiencies, etc. But at a fundamental clinical level, there is really no incentive today. And I use a crazy example. It's bordering on silly, but how many of us wore seatbelts in cars before seatbelts actually got mandated? Right? I don't think a lot of people did it. Everyone knows that seatbelts save lives. It's probably one of the biggest inventions, one of the key inventions that has played a role in saving lives is seatbelts. But still, only when the government mandated, only when there was that 500 rupee challan or that 100 rupee challan, did all of us start wearing seatbelts, and that too on the front seat. Whenever you sit on the back seat, you're never wearing a seatbelt. Although, I don't think there is any statistical proof that if you don't wear a seatbelt. So you get my point. So there needs to be some kind of, government drive or incentive or disincentive to not store data, or incentive to store data. And I think the NDHM is going to be key. So NDHM is this amazing initiative under the National Health Authority, the National Digital Health Mission, which will possibly be one of the world's largest healthcare digitization efforts, where similar to how we have a UPI ID for payments, there will be a health ID for healthcare, and same person, no matter, like, irrespective of socioeconomic strata, going from one hospital to the other hospital, your records travel with you, and that utopian kind of view. And I know for a fact that there are some very, very smart people that are trying to figure this out, and hopefully it materializes, and India gets to develop a leadership position globally on the data side of things. Now, coming to your question on research in India, for India, that's very pertinent, in fact, and specifically in the domain of AI, because all of the data is eventually going to be ingested by AI, and we'll all live forever, and all of that jazz. So the what is AI? AI, today refers to things that humans do, but now machines can do, right? That's, if we use that definition of AI in India, there are two types of research that are happening, right? One is, and which is more prevalent right now, is in India for the world. And we really don't see a lot of that because it's hidden in these large buildings in Bangalore. Whether you go to a GE, Philips, Siemens, Nvidia, Google, or these, hundreds of contract research outsourcing companies, where you have tens of thousands of scientists and engineers building AI tools that are used all over the world, and maybe not so much in India right now, but at least, so that part exists, and very much so. In India, for India, is a more recent phenomena. There's a lot of startups that are working on it, also because digitization, as you rightly said, has just started over the past decade or so. These startups are now getting access to some of the data. But just to reiterate the point that India is certainly a leader in AI research. We are not a lagger. So we have amazing startups like Cure.ai. We had the privilege of publishing with them the first paper on AI in the Lancet, right? And the Lancet is, like the leading journal across the world. So the talent exists, the data is coming up, the incentive we certainly have to figure out. But once we figure these three things out, there'll be no stopping. Is at least my utopian view.
Very encouraging. Thank you. Dr. Ramesh, I also wanted to hear from you. I mean, your strand definitely works on a lot of diagnostics and precision medicine. This is probably something that a lot of companies could also consume. And is this? Could you highlight the value of collecting data? Why we need to kind of gather data? Why it's important to know before we actually practice medicine locally? I think your mic is muted. Can't hear you. Yeah.
Sorry about that. Yes. So medicine is an empirical science at some level, and the only way you really know what's happening is to measure things out in reality. And there are two measures, right? There is cost and there is outcome, and enough and more has been done, which shows that there's wide disparity in cost, wide disparity in outcome, between different health systems, between public and private health systems in different countries, between doctors, individual providers. So there's so much variety out there that unless you have a systematic way of collecting, capturing all of the data, you would not have a real-time view what the efficiencies are. Obviously, you could do retrospective summarizations from time to time, and you'll have some ideas, but that's not as effective. Now, the incentive to do that obviously comes from payers. So in India, if you have largely individual payers, so far individuals don't have the power to go and look at this at all. But when you have large institutional payers, they're going to start asking questions. What is the efficiency of what I'm paying for? What are the outcomes? And Dr. Srinath talked about once you have a universal payer with the public system leading it and the private players fitting into that, then those questions are going to naturally arise. And once they arise, there will be a mandate and an incentive for every sort of every part of the system to then have that data and get it all integrated for the NDHM or with whatever infrastructure comes up. And the incentives would come from obviously from the payers, the mandate would come from the payers as well. And so overall, that's when everything will fit in place, right? And so, I mean, I can't even think of a world where without data, you can get a real-time view of where you're headed. I mean, it's historically, we've not had the luxury of that. So people have figured out ways and means, and now everybody gets by with something or the other. But that's the only sane and modern way to do things. I mean, no question about that. Because what we do at Strand and other places, we are just scratching. We are very small. We just scratch the surface here and there. If you have to make a sea change out here, that's where it has got to come from a large payer system mandating and incentivizing across the entire country. And let's hope that comes about sooner rather than later.
Absolutely. Professor Srinath, did you have anything to add about that? Because I did want to ask you about telemedicine. I mean, we are moving towards a slowly digital world. Everyone has a smartphone, and it might be a really convenient way. A lot of healthcare providers are saying to actually deliver medicine. But what can you tell
Well,
me?
telemedicine will definitely be helpful. There's no doubt about it, in extending the reach and ensuring that there is also a greater degree of access to quality of care by connecting the right kind of information and knowledge to the people in the field. But I wanted to comment on the AI part of it. See, one of the very important things we must recognize is that whether we are profiling a population group in public health or an individual in clinical medicine, there are multiple variables and therefore multiple data sets that need to be integrated. And context is very important because the context differs. You develop algorithms in North America, they may not necessarily apply to rural India or even one part of India to another part of India. We know that even in terms of the genetics, we are really now dealing with the super genome, not only our genes, but the genes of our microbiome. Similarly, you also have a super phenotype. Apart from the metagenome, you have a super phenotype of not only the biology, but of the behaviors, the social and environmental factors, which Dr. Sujata Rao spoke about. So all of these actually shape even your phenotype. So how do you actually integrate many of these in a locally contextual manner? So we do require a lot of data generation. Otherwise, algorithms developed elsewhere may actually be misguiding us in terms of managing either our public health problems or in terms of our clinical management of patients. So some of the principles can be brought in, but the actual algorithms have to be developed based on local data sets, validated here, and then applied, rather than actually saying that AI is going to be transportable across the world, irrespective of the context.
That's a important and interesting point. Thank you. Before we actually open this up to Q&A, I did want to ask all of you one common question. So maybe we could start with Sujata, and then I'll head one after the other. But what do you think is the next frontier? What is the next challenge? What is the next conquest in India's public healthcare system? Maybe you could tell us in a line or two what you think that is.
Well, I think the next conquest will be that we need to have a grip on our disease burden, which is galloping, both in terms of communicable diseases and non-communicable diseases. India is a big contributor to the global disease burden. So I think we need to really focus on health. And we can't shirk our responsibility by providing that measly 1% of GDP for health. It needs, besides money, a real political commitment at all levels to say, okay, we are going to be led by science and evidence and not by perception and what is attractive for getting votes. I mean, this kind of a temperament and mindset needs to be getting in, and and understand health in all its multi-sectoral nature of it, and move. I mean, it's a shame that 37% of our children are malnourished. So, I mean, I think it's time that we get a grip on how we define development, and really look at the new frontiers are going to be much more challenging to us, because if the climate change coming in with the environment being interfered with much more intensely because of our population growth, not India but globally, and with the huge amount of ability to transport communications being more efficient and so on, our own health security is constantly under threat, and we are getting more and more fragile as we get more and more powerful over nature. So I think it's a situation that we need to really look at in a very holistic manner. And the frontier will be to have a health system designed for, in our context, for our people, with our data. That is the main challenge, and I think we should get on with that.
I think Professor Srinath is all geared up to share his thoughts. Let's hear from him.
No, I'm fully in agreement with Sujata Rao, and I do not have any difference in that particular emphasis. But I would say that if we have to really look at what the future of public health in India is going to be, it has to be science-led and socially committed public health system that is efficient, equitable, and effective, and which integrates all sections of society. You cannot have multiple sections functioning independently and autonomously. And therefore, all of them have to be integrated into the design and delivery of healthcare. And it's not just healthcare, it's health beyond healthcare, as has rightly been pointed out. You have to deal with the social determinants of health, the environmental determinants of health, the commercial determinants of health, and act on all of it. And here, what we need is multidisciplinary education and research, which enables multi-sectoral applications with a problem-solving approach. So that is where I believe our health system has actually moved towards. And therefore, for that, what we require is a confluence of a more responsive public sector, a more responsible private sector, and a more resourceful voluntary sector. And ultimately, if we do that and engage the people in all of the aspects of health system design and delivery, then we'll have not just a public health system, but a people's health system. And that's what we must move towards.
Thank you so much. Yes. Dr. Vidur, Rao, about you? Let's hear from you.
So I think Dr. Rao and Dr. Reddy have both, said it beautifully. The only thing is I'll approach the question more from a business model perspective, right? Because so we have a COVID vaccine in less than a year. India ramped up testing to like more than 1 million tests a day. We have our own indigenous kits. We have our indigenous, so it's amazing, right? The way we fought it all. The single reason all of this was possible was because there was a business model, right? There was a market that AstraZeneca could cater to. There was a market that Pfizer, Moderna, etc., everyone could cater to. And unfortunately, there is no business model for feeding hungry children, right? There is none. And we think about this a lot, but how do you create a business model for Swachh Bharat? Right, you have so I live in South Delhi. So on one side we have NDMC, which is one of the cleanest parts in India. On the other side we have Faridabad, which was, I think, one of the dirtiest cities in India. And here we are, making overarching statements about AI and technology and all of that. But how do we incentivize the private sector along with the government sector to go and clean up cities? Right, so this is same thing with education, right? How does one incentivize a huge organization like Byju's, right, to give the right education to the right students in the right mode, having the right outcomes? So I think this is and like obviously I have none of these answers, but that I would urge all the audience, everybody who's listening, to think about it, like what can be a successful way of creating a private sector push for giving better nourishment, keeping streets clean, and all of that jazz. Or you think about philanthropy as a sustainable business model. But yeah, that's coming at it from the private sector lens. The reason COVID was successful was the model existed or was created.
So more creative business models and volunteers.
Bindur is so provocative that I can't help but in.
Ma'am, please, of course. I was hoping.
Can you give me a business model for being a decent human being the way you look?
I agree, ma'am.
A business model for honesty, integrity, just being clean, being healthy, and having all your children healthy, you know. Why
agree, ma'am.
we accept inequity and inequality and live in a society where there's so much of unhappiness and stress? You can't be happy. So the business model is that we need to have a healthy society because for our own selves. You can't be having a 99-year lifespan when everybody else is dying at 30, right?
Absolutely not.
So
correct.
I think it's like many things. I think.
Sorry, Kavya.
No problem at all. No problem at all. I was just going to say you're very correct, and we're hearing a lot more of this because it's true. I think we all need to think.
I'll tell you, ma'am. I'm coming from a very emotional side where literally. I was reading an article that talked about how during COVID, most of philanthropic money or a lot of philanthropic money was diverted from things like, female wellness and nutrition towards COVID-related things. And thereby more people are going to die of malnutrition or have died in 2020 than... Which is just shattering, because at one end we are celebrating and at the other end things actually got worse. So,
may I come in and say that actually investing in a healthy society is the best investment for economic growth and development. The moment we keep neglecting our health of the society, the economy will keep slipping on banana peels.
Yeah.
Correct.
Right.
Correct, sir. Absolutely.
Thank you. Lastly, don't want to miss you, Dr. Ramesh. Definitely want to know what you think is the next challenge that the public healthcare system should take on. What is the next big frontier?
Yeah, I think the biggest challenge obviously is to go from a macroeconomic perspective, go from the 1% of GDP to 2.5%. That's the government has laid out as a roadmap over the next few years. How to do that with given all the challenges at the moment. And that has to be figured out, and I guess it perhaps relates to what Vidur called the business model. At the end of the day, everything is a business model. Budgets have to be balanced, otherwise debt has to be taken, it has to be serviced. So, and at a macro level, everything is a big business model, and that has to be figured out. And obviously, there are priorities there, and you've got to prioritize health above a lot of other things, which is what multiple people on this panel are saying. And once you do that, hopefully the gains from that will feed back over a period of time so that your business model can be made to work. And so figuring that out is, I think, going to be one key thing. Once you figure that out, not as if it's a sequential process, but once you have a roadmap around that theme, then you've got to create the whole universal healthcare thing with a large pool of risk pool with where you're able to then draw the resources to be able to fund this whole thing. And then the next big frontier with once you have that is that the healthcare, the universal healthcare program is going to start looking at efficiencies and outcomes, which means the whole data and incentives and all of that around that theme will come up. And then once you have all of that, hopefully there'll be a lot done where a lot of market gets created for a number of different innovations that can fit into that infrastructure, and outcomes would be a corollary of all of that. From a very individual perspective, I would look forward to the day where you don't have to wait half an hour on a doctor. You sit at home, you're able to talk to him. You can see what that doctors or the institution's general outcomes and have been over the last several years. Everything is transparent. You can make decisions with knowledge. So those are all multiple, I guess. Things. Hopefully we'll get there soon.
That does sound really good. And what this whole panel discussion has, I think, what I can take away from it is that there's a lot of gaps and a lot of opportunities for people to engage, not just if they're doctors or drug makers, but also as people to actually contribute to our public healthcare system. So I'm really excited now to open up to questions. So let's just look at what people want to know from you guys. So there's one about medical devices. Where do you see the medical devices sector in India in the near future? I think either Dr. Vidur or Ramesh, one of you can take it, whoever.
Vidur, please.
I could take a shot. So I think fairly, I think it's going to do really well. Again, COVID has been case in point. Like a lot of the indigenous kits, a lot of the so my domain is diagnostics, so that's kind of where I look at things from. But I think there's also a huge market. So again, you have to look at things in built in India for the world versus built in India for India. And I think in India for the world is being handled beautifully by the whole Make in India. So I'm using all of these government terms, although I'm a completely apolitical type of person, but I just think they're amazing, right? So Make in India is certainly pushing towards that. I know that a lot of the big med device companies are actually looking at starting very large and elaborate manufacturing setups in India. Maybe driven by a little of the distrust that has come up from COVID, on one of our neighbors. But why not use that? In India for India is also very vibrant now. Again, there are a lot of government initiatives that are pushing for innovation. BIRAC is one entity of the DBT that gives out grants to startups and big companies, and there's just a lot of action, right? One of India's largest X-ray install base is actually an Indian company, and it's between two Indian companies. So we do have that. We have a startup in Bangalore that's working on building an indigenous MRI machine. MRIs are probably the epitome of technology, and they've built it all from scratch in India. So very vibrant, very exciting. But one thing I would say to entrepreneurs and people who are wanting to build med devices in India is that do consider, do always factor in a substantial amount of focus on international markets, because you will have to cross subsidize across countries, because India cost is a big concern, and for the same device in the West you could probably command a couple of X premium. So that's one of the general strategies, but overall very excited about and not just med device. Like when I say med device, I actually include software as a medical device within that domain. So and Ramesh's company has been one of the pioneers, right? Their product called Strandomics, like the entire world uses it. So so that's yeah, so very excited. And
Thanks, Dr. Vidur. We have another one that I really like. Technology can aid healthcare, but can technology ever replace manpower? For example, robots for surgery. And if you could give that in an Indian context, I think either Professor Srinath or Sujata or Ramesh, one of you guys, whoever feels like taking this question.
Well, technology can support and assist and greatly enable medical care or even public health functions to some extent, but it cannot replace. It can supplement, it cannot substitute skilled people. I mean, even if you're a surgeon and operating, for example, with robotics, you still have to assess the person, the patient who is a person incomplete. There could be multiple comorbidities that you need to identify. So there are things that come up which you're not always prepared for, only if you're depending upon technology. Whereas a skilled person can actually anticipate or even respond both to planned as well as unplanned exigencies, okay? So I think it is important for us to recognize that technology is certainly going to be a great enabler, but it can never substitute the human element in healthcare or in public health for that matter.
Thank you.
I really think that we don't need to go so fast as robotics or such advanced science, as that. Even simple things. I mean, like I'm told that in China, even at the decentralized sub-district level, you get CT scans, for example, all manufactured in China. Now, I don't know why we are unable to give enough incentives, perhaps, to our own manufacturers to see that they produce this kind of critical diagnostics, which have now become literally normal goods for getting a good diagnosis, for treating, and the outcomes are definitely better when you are diagnosed with the proper technology. You know, there's no doubt about that. So I think there is still, I don't think there's much of a policy, except to go on saying Atmanirbhar, that's okay. Yeah? I mean, that's all right. But you need concrete policy frameworks to say that I am a businessman, I have investment and money, and I'm going to get into this, as Vidur says, the business model that has to be there to incentivize me to want to get into medical devices. And it's time we depend less on importing technology and increasing more of our own, even a small syringes, I think, imported from abroad. So, you know, there's a huge amount, if we can, as I've always felt, if we can go to Mars with such precision, I can understand why we are not able to produce world-class X-ray machines and CT scans. And these are routine diagnostics today, okay? So I think public policy is a bit deficient on this score. A good legal framework and a very strong thrust on developing the medical device industry. It's lagging for many, many years. It has been pointed out in every document, but we have been negligent on that, and public policy needs to move far ahead and very quickly.
Thank you. Another interesting one, and I hope I take this question, I think it would be either Professor Srinath or Ramesh. I would really like one of you to take it. But how do we create a health insurance scheme for the poor? Is that something that is possible?
Well, for the poor, actually, we do need a tax-funded system. So say that poor are going to be contributing is going to be very difficult, because even if you're talking about a salary reduction, about 90% of our people in the health workforce are an informal workforce. So you can't have salary reductions. And many of them are anyway below the poverty line too. So what we really require is a public funded system, which is principally funded by tax. That's why most countries do that. If you look at what is the share of public financing out of the total health care, there are many countries in Europe, including the United Kingdom, which are above 80%. Even the United States, which is supposed to be a poster child for privatized healthcare, the public financing of healthcare is 48%, which is through Medicare and Medicaid. So you cannot really have a situation where you are going to be only dependent on an insurance system for the poor, and in case they're unable to pay a premium, leave them to the mercy of ill health. So we do need a proper universal health coverage system, which is principally tax financed. And this is what all the economists all over the world also believe.
Sir, would Ayushman Bharat not that is precisely that, right?
Yeah. Ayushman Bharat is very much that, except that it is covering 40% of the people who are relatively poor or otherwise vulnerable. The question is, what about the missing middle? Because people above the poverty line are also a little vulnerable. So there are ways in which we can do it. Either you can still cover them from tax funding, or at least give them an opportunity to participate in this program through income graded premium payments, if they can do that.
All right. There's another one here that I would like to take, which is what is the ground reality of the government schemes and incentives in all perspectives? And is it possible to mold the perception of our society from their fundamental rights towards fundamental duties? I think this is a pretty powerful question, but I think, Sujata, you had mentioned this briefly, that it's not just fundamental rights and what's owed to you, but also our fundamental duties. Maybe you could tell us how these schemes are going to encourage that, or are there any incentives to actually motivate fundamental duties?
So, you know, in our anxiety for populism, we don't necessarily make our citizens also duty-minded. I mean, the citizen also has to be a bit obedient and follow government laws. I mean, they say, please wear a mask, nobody listens. They say, please don't, please wear a seatbelt, nobody listens. And when poor Mr. N.T. Ramarao tried to bring a law to say you must wear a helmet, because all the doctors in Hyderabad went to him and said so many people are dying due to accidents and injuries and so on. The High Court interfered and stayed it. I mean, just about everyone interferes with small things like even bringing in regulations to channel behavior towards good health. So the citizens also need to know that they have to be good citizens for public health. I mean, their good behavior impacts on social behavior. It's not, individual is not an isolated feature on his own. And often in most countries, this also comes with a lot of stiff punishments. You can't go and dirty a park without having to pay a $500 fine. You don't wear a helmet or you don't wear a seat belt, you are punished and you do face a very stiff punishment. So I think it's time that we get away from this kind of laws. We say pay 10 rupees or 1 year in jail. I mean, there's a comparison between 1 year in jail and paying a 10 rupee fine. So this kind of, bureaucratic muddles we need to set aside and come up with proper systems where the citizens are educated on what is good healthy behavior, and also disincentives are provided to see that if you are deviating from what is good societal behavior, you're brought back onto the path. Don't spit, don't urinate, you can't publicly defecate, things like this. And the municipal laws that need to be enforced, where you need to keep places for parks and for cycling and these kind of enabling infrastructure so that people are able to live healthy lives. So there is a lot that needs to be done as for citizens' duties as a part of their obligations to be good citizens and ensure that diseases are not spread the way they are spreading here today.
Yes, and one last one, I think we should take this one too. What is the future of healthcare jobs in India, and what skills should one focus on without the fear of AI? I like this one.
Without
the fear of AI, without the fear of AI taking over our lives and our jobs, what are the skills that we can, learn and develop without the fear of technology taking over? So, anyone?
Well, basically, there are so many jobs that are available in healthcare and public health, which certainly are not going to be replaced by technology, though they can be enabled by technology. A lot of things in primary healthcare will have to be done essentially by people. And a lot of functions, even in whether it's delivering a child, is going to be done by people. Immunization is going to be done by people. Contact tracing can be helped by apps, but is also helped by people. And there are many other areas in which actually in public health as well as in clinical care, you're going to be requiring a large number of people. And in India, we are very short of skilled health workforce in multiple areas. And there's a great opportunity for generating employment. And even globally, there is a huge shortage again of skilled workforce in many countries. And even in high-income countries, the workforce is shrinking because of aging populations, and you're not able to find replacement into the working population. Mm-hmm. So we have a great opportunity to train people who are adequately skilled and who can actually meet the shortages in our country and may even actually be available to meet the global health workforce requirements. So there are multiple areas in public health as well as in healthcare delivery where, I mean, for example, mental health counseling, you're not going to get, you may be able to diagnose depression by AI, but mental health counseling has to be done by a person. So therefore, there are so many areas where you cannot have people replaced completely.
Yeah.
Just to add one dimension to that, Kavya, is like, especially for the youngsters and, like people who are starting their careers on this, who are seeing this video, there is also an over accumulation of healthcare workers in the big cities, which gives this, false assurance that, oh, there's so many nurses, there's so many doctors, there's so many hospitals, etc. But, so for anybody who's starting to build their career and in this technology enabled world, like, maybe it's better to focus away from the cities, right? And depending on your comfort level and where you hail from, like, I personally have friends who are now moving back to their hometowns at the age of like 30, 35, and are setting up clinics and hospitals there because, and shoot me for this, but the business model exists. so
Till the end without that, but yes.
yeah, because like everybody aspires to come to a Delhi, Bombay, Bangalore, Chennai, but they're like 99.99% of India is not there.
Maybe whether you should stop calling it business model and say motivational and reward system.
Oh, thank you, sir. Next webinar, ISF.
Thank you. Thank you, Dr. Wizard. Thank you, Professor Srinath, Dr. Ramesh, Sujata. Thank you so much for making it. This was a really interesting discussion, and now I'll head it back to Shu to take it over from here. Thank you.
Thank you.
Thank you. Thanks so much.
Thank you so much to all of the panelists who came for this discussion. On behalf of Team ISF, I'd like to extend my heartfelt gratitude to all of you for taking out the time to do this. In our attempts at bringing science closer to society, we really do want more researchers and scientists, entrepreneurs to come together and speak to the public. And you all have taken out the time to do this, and we're so grateful to all of you. Dr. Hariharan, Professor Reddy, Sujata ma'am, Dr. Mahajan, thank you so much for your time. And I'd just like to thank Kavya. You have beautifully moderated the session and you took so many efforts to put all the questions together. Kavya, it was a pleasure having you. Thank you so much for joining us.
Thank you very much. Bye.
Thank you. Thank you.
Thank you so much. I think it's very interesting that we all got to hear some very different viewpoints at this panel discussion. I'm sure all of you gained a lot out of it. So as did I, and it was such an enriching experience being in the company of so many wonderful researchers and scientists. And I think it's now time to begin with our next session. As you all, I don't know if you all heard, but Professor Reddy in his last statement said that you might use AI to diagnose depression, but how do you actually use technology to counsel someone with depression? And we are going to have a very interesting session on mental health. May I please invite Ms. Neha Kirpal and Professor Saxena to turn on their video and audio.
Hello, pleasure to join.
Thank you very much for having us.
Thank you so much, Professor Saxena and Neha ma'am, for coming in. It's such a pleasure to have you both here. I mean, this topic is now so much in the news, and it needs to be spoken about at public engagement platforms and needs to be spoken about without any stigma. And we're very grateful that you both took out the time to join us here at the festival. I'd just like to tell everybody, give a little introduction about Professor Saxena as well as Neha Kirpal. Professor Saxena is the professor of the practice of global mental health at the Department of Global Health and Population at the Harvard T.H. Chan School of Public Health. He's a psychiatrist by training and has served in the World Health Organization since 1998. Neha Kirpal is the founder of India Art Fair, and she's a passionate social entrepreneur and has been working in the field of mental health for the past 3 decades. She is the co-founder of InnerR, which is a digital mental health platform. And Neha ma'am and Professor Saxena are together the co-founders of Librum, which is the world's first strategic think tank for mental health solutions. And this discussion has been brought to all of us in association with Librem. Thank you so much yet again for joining us. It's such a pleasure to have you on board. We are going to be talking about common mental health problems associated with the youth. And now I would like to invite both Professor Saxena and Neha ma'am to take this discussion ahead. We will launch the polls in just 2 minutes. I just have a slight technical glitch here. So if you could just take it ahead, and I will make sure that the polls are ready in 2 minutes, if that's fine.
Thank you. Thank you very much for that introduction and for setting up a forum to discuss something as relevant to all of us as mental health. We look forward to the poll, but while we get that set up, perhaps just a quick introduction from our side about Librem, which was really set up with the idea of looking at system solutions for mental health. You know, as we look at the changing world, we look at organizations, governments, institutions for all ages, but particularly with a focus of young people. We realize the level of transformation that is needed to provide the sort of social support and framework for people to really sort of thrive and be productive. A huge level of unpredictability in the context of COVID and everything else that we're dealing with in the course of our lives. And so Librem really set out with that vision to be able to support organizations in thinking through mental health solutions. For me, this is an incredibly personal journey. I've spent many years of my life at the receiving end of a whole range of mental health traumas that our family has gone through. So I come at it as a passionate social entrepreneur. You know, Dr. Shekhar Saxena, of course, has, and also Dr. Vikram Patel, who are co-founders, have a tremendous legacy of working in this space and working in a global context, but looking at a whole range of demographics and people and trying to see how we can solve for access, solve for acceptance, what is the role of technology, and how do we really build a more inclusive, mentally healthy society. So with that, would love to see if the poll is set up, and then we can begin our session.
Right. I'm really sorry. It's just taking a minute more here, but I'd just like to tell you both that we have a couple of questions that have started coming in. We had invited questions for this session. So maybe I could just tell you about the general questions that we had as part of the session that we're having right now. And the attendees have told us a few problems that they are dealing with in their personal capacity. So maybe I could just tell you the general umbrella theme of what we have been. So one aspect that we have been told about is how to deal with mental health issues if somebody else is projecting something, if somebody else is dealing with something and you're on the receiving end. Secondly, one major aspect that we've had was how does the pandemic affect children and how do we make sure that their mental health remains stable? The third question that we have received is a lot of peer pressure and exam pressure, peer pressure, pressure to fall prey to substance abuse. How do we stay away from it? And the fourth question that we generally have here is how do you convince someone to take help, take professional? And those were the four most often asked questions at our forum. And with that, I can quickly launch the poll that we have been planning. So these are the two polls that have been requested by our panelists. I would request all our attendees to kindly quickly answer the polls that you can see on your screen right now. And you can all see the results of the poll on your screens right now. All right. I think I'll now move on to the second question that was asked to the poll, and here. And the answers are on your screen. Okay then. Neha ma'am, Professor Saxena, over to you.
Thanks very much for that, also for the introduction and conducting the poll. Shruti, it's such a pleasure to join. We have a number of questions and we also have the responses from the poll, but I would like to begin from the beginning, just making sure that we put the whole thing in the context. I'd like to make 3 points to begin with. One, and these are all important before the pandemic also, although things have changed a little bit, but mental health has been important and will remain important for for the young people, especially for all times to come. So I'd like to make 3 points. One, mental health problems are common, and they are very common amongst young people. As many as 50% of all mental health problems start before the age of 15, and as many as 75% before the age of 25. So we are talking about mental health issues which start in the young period, during the adolescence and young adults in the majority of people. One could ask, what are these mental health problems that we're talking about? There are common problems like anxiety, like depression, like adjustment problems, and also in many countries, including in India, alcohol problems and drug problems. So these are the common problems. There are other severe problems, but let's talk more about the common problems. And a very large number of people, especially young people, are affected by these problems. The percentages are as high as 5 to 10% of all population. So if there are, for example, 200 people attending this webinar, then it's likely that between 10 to 20 people have this problem now, and at least 25% people will have it during some time during their life. So these are common. The second point is that they cause a very large amount of disability. It's not true that mental health problems can be lived with and one can lead a normal life. Anxiety, depression, substance abuse problem, they affect our lives in a very significant manner. And there is a lot of disability which is there. We cannot work very often, cannot work as much as we wanted to. Our education is impaired. Our role functioning in the family is impaired. We cannot look after our family. We cannot earn as much. So these are seriously disabling problems, even if they're common. So that's the second point I would like to make. But the third point is perhaps extremely important, and that also was referred to in some of the questions. Can something be done about that? And the clear answer is yes. These problems can be recognized, these problems can be helped, and that help can be given by family members, by colleagues, and in many cases, professional help is also required. And I think we have reached a stage in the last 2 or 3 decades that most of these common mental health problems can be fully corrected. They can be symptomatic relief, they could be cure, and a variety of interventions, a variety of treatments are available, which can actually help the people who are suffering from these problems in a very serious way. It's like going to a doctor or going to a nurse for your physical health problems. And similarly, mental health problems can be helped by the professionals. So we need to recognize them, we need to seek help, and we need to get help so that the disability can be avoided. So these are the things which are important, have been important all the time. But of course, COVID has put a lot of additional burden on that. And I'd like to invite my colleague Neha to talk a little bit about what is happening during the COVID pandemic period for young people, especially for their mental health problems.
Thank you, Shekhar, for that. And as we understand statistics, we also understand that each and every person has their own unique circumstances, and we're not a statistic to ourselves and in our families and in our communities. And so, as you folks would know, this is a period that has been challenging at so many levels, right? There are economic difficulties, there are job changes, there are losses because of health reasons, there are losses because of COVID infections in families and in our friend circles. And a lot of this is producing anxiety. And it's anxiety that we may not be able to address because we are so caught up in the working from home. Perhaps several people are parenting or being parented. And it is a really challenging environment because it is something we have not experienced in the course of our lifetime. Now, if you look at that and you look at the length of this period, one can easily see how the effects on mental health of this level of disruption are not just about this year and it'll end with the vaccine. This is something that we are going to feel for a long, long time in the short term, mid-term, as well as long term. Because the lives of young people, and I'm talking as young, I mean, I have a daughter who's 8 years old. And so right from the very young age, children's lives will change forever in some ways, right? And so the question is really, what are the big changes and what do we make of them? And to what level can we say, look, it's a matter of self-will and just sort of being strong, fake it to make it, tiding over, etc. All the usual reassurances. And at what stage is it a little bit more complex, and perhaps there is a need for clinical support and professional help, and perhaps we want to be able to be open and aware in order to help ourselves and those around us, right? In the work that we do at Inner Hour, we have people from over 150 cities across the country. There are 800,000 people using the platform today and looking at the kind of disruption in terms of sleep, eating habits, day-to-day functioning and productivity. We can easily see the effect that it has on women. We're seeing a lot of increase in addiction issues, in domestic abuse, and just in general, the anxiety and fears that people have. They have to go somewhere. And sometimes, as young people, we would tend to either act in or act out, right? So it's a really challenging time for caregivers as well as those who are sort of going through all these changes in times today. Think about people who are making career changes or, in education at a stage where many of you are, where there is a degree of uncertainty. And there is perhaps an inability to talk about it because, you may feel more triggered. These are all the realities of our present time. A lot of people are turning to digital mediums. A lot of people are turning to friends. A lot of people are turning into a greater degree of isolation because they are not able to necessarily help themselves. So if you break that down, there are social factors, there are economic factors, there are people who are already suffering in some way or the other from some degree of mental illness or physical issues, and their problems have become that much more exaggerated. So a combination of all of this is really bringing us to a point where if we don't really recognize at what point it is beyond our ability to productively manage ourselves, it is beyond our ability to handle with the family and friend support and not take professional help, then it might be something that is that's really sort of damaging in the midterm and long term. So I would just start by almost sort of at a blanket level encouraging everyone to sort of check in with your feelings. Shekhar has often talked about maintaining mood diaries, doing a bit of meditation, having some sort of an emotional touch base with yourself and those around you. Physical distancing, it does not necessarily mean social distancing. In fact, we're all interdependent beings, and we crave that connection. Often just that isolation creates a sense of abandonment in us, right? So what can we do to be able to increase our connection with ourselves, be able to be more self-aware about where we're at and also those around us? And if we find that something is not right, and not right over a period of time, maybe not just a couple of days, but a few weeks have passed, and there are still sort of difficulty sleeping, eating, changes in behavior, changes in social interactions, then we try and do something about it, right? So these are some of the broad observations, and Shekhar, I'd love for you to sort of point to now what kind of, if we were to observe these patterns in ourselves and in others, what might be the first few steps, and the kind of interventions that people can seek out for themselves, and that might help to begin with, and what should people be watching out for?
Thank you very much, Neha. I just want to go back to the polls, and it was very illustrative to see that only a very few people were not affected in their mental health by the COVID pandemic. And the vast majority was affected to some extent, and some of them very seriously. But the second poll also was very interesting. What can you do if you observe a mental health issue? And the vast majority of people actually said that we need to start at least talking. And I think that gives me a lot of hope, because you can't leave them alone. You can't always refer to them to the professionals, but certainly you cannot provide very superficial kind of reassurance. So this was exactly what we should be anticipating, that you at least start a conversation. And that really speaks to the high level of awareness that our listeners have in this area. But let me just go ahead and answer another question that has just come up. What is self-care, and how do we encourage self-care? What can we do really? And Neha, you have already explained a few of the strategies that one can use for self-care. But let me add a few more. The first step towards self-care is to recognize that we might be having stress, we might be having mental health issues. And I think that's important for all of us. Mental health is not only about people who have a mental disorder, it's about all of us. And especially during the COVID period, we all are moving on this dimension of mental health from being very well adjusted to having some psychological issues, having psychological symptoms, and sometimes a clear disorder. And we're all moving from less stress to more stress, unfortunately. And we can keep a tab on how we are feeling, but also what is affecting us more. So a little bit of introspection, as well as keeping a diary, keeping some kind of mental check or a check on a paper or an app, is actually quite useful, so that we can recognize what state we are in, but also what is affecting us. Is it that we are not sleeping well? Is it that we are not eating well? Is that we are having a lot of job problems or family issues? During the COVID period, a lot of people have been confined with people within the family, sometimes within the larger family, which obviously can be supportive, but can also be very stressful. So as Neha said, it is all contextual. It's about how you react to the situation as opposed to somebody else. And in many cases, being confined with a large number of family members is a very serious stress. So we need to think about what we can do. What can we do? One, we can keep a tab on that. But the second, we can look after our own health and our own mental health in a variety of ways. The first issue is we need to take that seriously. We can't ignore it. So just like we look after our the exercise that we do, the steps that we take, the cholesterol, the blood pressure on the physical side, we need to look after our mental health side by seeing what our emotional state is, how much we are sleeping, how much we are stressed, and so on, and can do something about it. We all vary in our coping mechanisms from person to person. But it's important to see to it that we have some time to ourselves, not only give time to others, which is very useful, but also some time to ourselves. We can begin the day by recapitulating what we need to do during the day, what might give us pleasures, what might be more stressful, and prepare ourselves for that. And at the end of the day, we might recapitulate as to what we were able to achieve, take pleasure, take pride in recognizing that we were able to achieve, and be soft on you, not hard on yourself, because even during the COVID period, things are more difficult than usual. So derive a pleasure and a sense of achievement in sometimes in small things rather than just looking for larger things. And see what created more stress, what created more satisfaction and reward, and how you would like to change that tomorrow. So take one day at a time and plan for it. Also then evaluate how it went and do course correction. What can you do tomorrow which actually gives you more satisfaction, more achievement, and can satisfy your needs and others' needs in a systematic way. Of course, as I said earlier, look after your sleep, look after your nutrition, see to it that you indulge yourself in some pleasurable activities. It's not that you have to continue to do everything that is needed. Listen to music, read something, watch something, and find what gives you more pleasure. And that's really very important. Lastly, if the stresses continue for a long time, it's interfering with your work, with your responsibilities, think about talking to somebody that you trust. You can't talk to everybody about your mental state, but there must be somebody in your family, amongst your colleagues that you can talk to, confide, talk about your feelings, and seek help. And if that does not help, seek professional help. There is no shame, there is no stigma in reaching out and seeking help, either on a website or to somebody that you know. Talk to a psychologist, talk to a trained doctor, talk to a psychiatrist, and seek help, because many times by not seeking help, we are allowing things to worsen. And then it becomes increasingly difficult to get back to your normal. So those are things that one can do, one must do, and take one's mental health seriously and do what one can do about this. Shruti, I want to get back to you and see if there are some questions that we have forgotten to answer, or are there some fresh questions that you would like us to answer?
Absolutely. We have many questions that have been lined up here. So let me just quickly start asking you a few. So one question here says that how do we know if somebody just needs to talk to someone or if they need professional help? How do we distinguish between the two?
Well, that's a very important question and a very practical one. I would say that, as I was saying earlier, mental health issues are important for all of us, and we all have some amount of stress, either small or large. In fact, I will go ahead and say that if we did not have any stress, we will not be as effective as we are, because we get up in the morning, we have things to do that stresses us, and we go out and do it. Otherwise, we perhaps take it much more easier. So certain amount of stress is constructive, is adaptive, and is necessary. But it's like inverted U-shaped curve. Some stress is necessary, is effective, but too much stress brings our effectivity and our efficiency down. And so we need to really see where we are on this curve and try to maintain that. And this question that your listener asked is very important. How do we recognize whether we have too much stress, whether we need help, and whether we need help from just talking to somebody or need professional help? WHO, the organization that I worked for 20 years, has this classification of mental disorders. It's called ICD. And it defines mental disorder as a significant amount of either distress or disability, which interferes in a substantial way with our lives. We cannot get as much out of education that we want to, we cannot work as much, we cannot look after family members that we are supposed to do for at least 2 weeks' time. and a substantial amount of disability. So yes, if we have a small amount of stress, we are still able to work normally, let's talk to somebody. But if we are not able to work, our work is significantly impaired, we have serious and recurring thoughts of pessimism, sometimes going on to even suicidal wishes, suicidal attempts. Those are the times where we really need to seek professional help, and sometimes it can be very urgent. I would say begin with talking to somebody, take advice, and if it doesn't resolve in a couple of weeks' time, think about taking professional help. Thank you. And I just wonder whether Neha has anything to add, because Neha has a lot of experience personally and within her family.
Yeah, thanks. I think it's really a question of looking at all things from mental health to mental illness as a continuum, right? So if we think about it, there are times in our lives when we all struggle, and the question really is whether we are able to navigate through that period on our own, whether we are able to navigate with the support of those that we have around us, and whether in spite of all of that, we are finding it difficult for long enough in a way that it is impairing, as Shekhar said, our productivity or our relationships or whatever it is. Ultimately, mental health support for ourselves and those around, we tend to put off till it becomes critical. And the whole thing is to turn that on its head and say, what can early intervention feel like? What can we do when we start beginning to see the cracks? What can we do to support ourselves? I share this because, with a lot of pain, I've seen a lot of mental health issues get to the hilt in my own family before any action was taken and any kind of treatment or sort of care was provided. And we've had many, many years lost as a family in terms of sort of relationships and quality of life because we couldn't necessarily act in time. And sometimes the realization is not there in the person themselves of the degree of their suffering, and that's when the role of those around becomes important. So at a macro level, and I'm looking at all the questions here, and so I think the broad framing that we have to think about is there are times when we are feeling good in our own skin, where we have a healthy sense of balance in terms of our place in the world and our relationship with our work, with our peers, with our loved ones. And there are times when some of that is broken and fractured in some way. And we have to really ask ourselves, what is it that will work for us? While mental health treatments are available, but what works for different people is unique to them. And so you could be in need of therapy services which you can access. There are now lots of helplines that you can access. So just speaking about the actual forms of help, there are self-help platforms like ours where we say, there is information available. There are self-help activities available on the platform. There are mood trackers. There are check-ins. There are things that you can do to help yourself. So that's something that INNERR offers, and there are other platforms as well. Then there are telecounseling and teletherapy services that you can access, where you can speak to someone in a whole host of languages, and you're able to get some degree of help and support, perhaps through a difficult patch, and then you can go back to self-help sort of ideas. There are also helplines that are crisis helplines. So a lot of people who were feeling depressed are suddenly feeling like self-harm, perhaps, or feeling a sort of an exaggerated symptoms. There might even be suicidal tendencies. So it's about recognizing that and making good use of the helplines that people can access, and we can share many resources and numbers with you folks. And then there may be times when someone here or in your family and friends might need psychiatric support, might need medication, and really there is a sense of putting that off or not going down that route because we want to try and control our mind. And mental health issues are often looked at as a mental weakness or as a way of lacking self-control. So at what point do you go from being a social drinker to being an addict, right? How do you really know when that tip over has happened? These are all things that are that could be sort of just behavioral or psychological, or could be clinical conditions that you do need medication and psychotherapy and a whole combination of things to help support and work through. So I think I'm hoping that as I look at some of these questions around around addictions, around depression, around how do you talk to people about how do you know when you need help, and how do you know when you need to go seek professional help. I think these are some of the things that that might help in answering those questions.
Absolutely. I think there was so much. Yes, Professor Saxena, please go ahead.
Shruti, I just wanted to also answer the question, how relevant, accurate are online questionnaires?
Yeah.
I think there are many questionnaires which are very useful, very accurate, and but one has to go to a credible source and not just do a Google search and find something. So go to a credible source like WHO or like some of the apps that Neha talked about, and then you can be assured that these have value and these will not lead you in a wrong direction. So choose carefully, but these are very useful.
Yeah, I'd like to mention, sir, everybody at some point of time has gone through stress. And stress is not something anybody escapes in their life, in the lives that we lead on a day-to-day basis. But as Neha ma'am correctly mentioned, at what point of time do you think that the stress has tipped over to the other side, where it is not manageable on your own end? So I think that was very, very insightful, and it covered a lot of questions that we have been asked. Let me just move over to the next question that we have here. So one very interesting, I think Neha ma'am can answer this. So what was the inspiration for the InnerR app, and what were the obstacles that you faced while developing it? I mean, because this is the stigma surrounding mental health is something that is very, very prevalent in society. So how did you go about with the entire process of completely basing an app on it? Love to know.
Yeah, I think, just to make a quick point on this idea of stigma, I think the general discourse is, and we all feel like mental health is very stigmatized, but, looking at the folks in this room and also just young people across the country, and we have a lot of young people on our platform as well, there is a great deal of openness in talking about it. I think it's a generational shift as well. And as we talk to young people and we work with a lot of communities that are exclusively for young people, we see that they are open, they are talking about it, they want to address it, they're open about their political views, religious views, sexual views, open to talk about mental health issues. And there is a sense of self-acceptance and verbalizing who they are, right? So I think that's a very empowered place to be. And I just want to put in perspective that the stigma may be a narrative. And it's certainly true, and it may be true for 90% of the people. But the point is that the millions, tens and 20 million people. I mean, if we look at the India numbers, there are 200 million people suffering from mental health issues. That's 70-80 million people with depressive disorders, 20-30 million with psychotic disorders. You look at the suicide rates in India. There's a suicide every 17 seconds. And as at the same time, if you contrast that, as Dr. Shekhar Saxena said, the idea is that you can actually diagnose a lot of the mental health conditions before the age of 15. So what is it that makes us let it be and let it go for the longest possible time, right? And it comes from I feel there's also a cultural concept around somebody asked the question around self-care. What is self-care, right? And I don't think we are necessarily brought up to think like that. We think about our role in the community, what we should do for our family, how we should work, what difference we should make in our lives. But we don't really think about how we should nurture ourselves, right? When we go through childhood abuse or challenges, it could be sexual abuse, it could be parental issues, it could be peer pressure. When we go through all of these issues, the impact that it has on us as a young generation, and the fact that it goes unaddressed, right? And we are expected yet to just simply perform, right? And tick all the boxes across every milestone in life. I think if we just stop with that, and COVID has been a blessing in that regard, right? If we just stop with that whole trajectory and say, bottom line is that the one person I need to live with is myself. The one person I need to understand is myself. And if I'm able to do that self-care, that is a mysterious notion to some of us, then I will be able to do that better for others as well, right? And a recognition of that makes us more internally driven than externally stimulated. It's one of my pet phrases because I feel it really puts the self in context. And so if we're talking about self-awareness, self-acceptance, self-love, self-nurturing, what that might look and feel like to different people is different. For some, it's their relationships. For some, it is good food or a great movie or music. But we must give ourselves that. COVID has given us the opportunity to recalibrate our decisions and how we look at our relationship with ourselves and others. So I think there's a real opportunity here to sort of function in a different way going forward as well.
I think there is a very interesting question that I'd just like to add in, to that point that you made, that there's a generational shift in the way that we, the younger generation, has started looking at mental health issues. You very rightly pointed out that, the very fact that there are so many questions coming in for this topic, it just shows that people are opening up and are no longer stigmatizing the issue. But one interesting question that we have here is, how do we get our parents or grandparents to accept mental health struggles and issues and address them? So Professor Saxena, if you could just share your thoughts on the same.
Yes, it is a challenge, but it can be tackled. And I think we need to use the context that they are having rather than the context that we are having. So explain in the language that they can understand, and then let them see the utility of what we can do. So if you take mental health issues in the abstract, then it's very difficult to understand. It's very difficult to remove the stigma which comes enveloped by. But if we really look at each issue separately and say, what is going wrong and what can be done about it, and prove maybe by small examples.
Did we lose Professor Saxena there for a second?
Hi, am I audible?
Yeah, you are. I think Professor Saxena's frozen at the second. Yeah.
Yeah.
So, ma'am, maybe if you could just, add to what he was saying about how, this issue could be addressed with, our parents or our grandparents, since you speak from a personal experience in your family.
Yeah, I mean, it's mental illness in the family affects everybody across generations and affects all family members. So let's say if there's one person suffering from addiction or any psychosis or any kind of depressive disorders, it affects everybody. That's why these are called family diseases, right? And they do have an impact, and we must recognize that. As a caregiver to somebody, it is hugely sapping. There is guilt, it is toxic, it is difficult, there are a lot of balance issues. So there's a lot that it takes even to support somebody else. So first things first is to recognize that. The second is that, when you think about addressing these issues across generations, sometimes you will find the openness and the support and the understanding to do that, and sometimes you will not. The question is, what can we do within the limited resources and opportunities that we have? What are the things that we can do to help ourselves or help somebody else? So I think it's certainly important to have the conversation. Panels like this, which we, Shekhar and I have done so many of in the course of the lockdown and COVID, have been a little contribution in that, I feel. But conversations across generations, talking about mental health issues, the more media talks about it and platforms like these, it certainly helps. Recordings of sessions like this as they're shared with parents. I know that there was a wonderful session done on sexuality and mental health recently by a child psychiatrist, and those sessions were shared for people who were then going, coming out of the closet in their homes and talking and sharing that and saying, look, I wish we had examples like this to refer to when we were 5 years ago or 10 years ago, when we were younger. But the point is that this conversation is happening. There are enough and more resources available. When you look for communities, when you look for content in different languages, that can really help you and understand and help you explain to other people. So I would really urge that it's one of those things that takes a lot to break as a perhaps as a stigma or as a notion. But it's very, very important to keep pushing that conversation. And whether it makes an impact on somebody else or not, it's important to do what you need to do to support yourself. Because sooner or later people will understand, but you have to be able to recognize your needs and try and cater to them the best possible. Shekhar,
Shruti, I'm sorry, I logged out, but I'm back now. I just wanted to answer one question which I saw raised, but how can we take care of procrastination? And I think that's an issue that many people face, especially during the young life, but also all through. I think I have a couple of tips and suggestions. One of them is look at the issue that you are postponing, not as a big problem, but as a combination of various small issues and small problems. So break it down and see which part is scaring you off more than the other parts, and deal with the parts which look more manageable, and then you will be able to tackle the bigger parts. So break it down, see them in their parts, and tackle the parts that you feel more comfortable about. The second tip is that do it at the time that you feel maximally effective. Don't wait till the time you're already tired. So do it early in the morning, take it on, do a small bit, and then do the later bit maybe tomorrow. So those are things that one can really help with, but it's a normal phenomenon. We all do it. Sometimes we do it more than others, but it can be helped. Lastly, if it is a symptom of serious anxiety and depression, then take care of those things rather than just to try to tackle the symptom of it. So keep a tab on your emotions, see how stressed, how anxious you are, break down the issues and tackle them one by one. Another tip is when you achieve something which you have been postponing for a long time, give yourself a reward explicitly. Go and indulge yourself in an ice cream or talk to somebody you love. And that will really help, because there is always a connection between reward and then being able to do it again. So, condition yourself for that. Thank you.
That was very well put, sir. I think like you broke it down into little bits there, and very tangible points that we could just take into our everyday life. If we could adapt a little few things that we could adapt in our daily life, could actually maybe really help improve mental health on a daily basis. Ma'am, you were saying something.
I was looking at these questions around mental health struggles, chronic. Is it possible to overcome them? It sort of seems like a real uphill task when you begin to look at some of these issues. It feels there is a sense sometimes of helplessness. Some of it is coming from your own sort of denial. Some of it is coming from the social pressures. Some of it may be coming from not knowing what to do. Some of it is sometimes not having a vocabulary. I know something is wrong, but I don't know how to express it in a way that it will be understood or taken seriously. In many languages in India, there are no proper words even for explaining mental health conditions. And oftentimes there is a negative connotation. And so it is the connotation is such that it is not respectful. It doesn't give the dignity that that emotion or that person deserves at that moment. And these can be very, very debilitating. My point is that the starting is the hardest. And after that, actually, if you think about the way services are available today and designed in the mental health ecosystem, many of these conditions, they're all certainly treatable, and many of these are curable. A condition like depression, for instance, that ultimately for some fraction of cases goes all the way to suicide, is something that is highly treatable, and most people are able to come back to a great degree of productivity and normal functioning and able to have healthy, happy lives. But it is so difficult to imagine when you are in such a dark space, right? I just want to be able to share here very personal examples. I mean, as a child growing up in this country in the 80s, my mother had schizophrenia, and it was in a time when people didn't know what schizophrenia was. She went untreated for 25 years, and we spent our childhood in that darkness. And growing up, my brother struggled through extreme depression, looking at all the pressures that were on him to be able to perform in spite of that kind of childhood. 2 months ago, I lost my brother to suicide, and it was a very long and hard battle for him. But these are very, very tragic moments when you know that these conditions can be treated, these realities can be prevented. But because we didn't help ourselves, and because maybe our family didn't understand, maybe we didn't access the right help at the right time, whatever the reasons might be, that there is a life lost, or there is a love lost, or there is an opportunity lost, right? So I share this because I believe that one of the hardest things to do is do exactly this, right? Which is really to share and own our vulnerabilities. I mean, this is my fourth startup today, and yet I'm struggling in my own family with mental health losses. So we are all suffering in some way or the other, and we all have the ability to make some change and some difference, whether to our own lives or those around us. So I would really sort of take that message to say, these are highly treatable, preventable conditions, where the earlier that we try and deal with them, the more able we are to give recovery, and to give the promise of life and hope. And helplessness does not mean hopelessness. And please hold on to that, especially if you're having a bad day today or anytime soon.
That was really very insightful. Thank you so much for sharing that. I mean, I'm sure it wasn't easy for you, but I think that there's so much to learn from our own experiences, as well as if someone is sharing something from their own lives, they've obviously gone through a lot, and have reached that stage where they're able to talk about it. It comes with a lot of acceptance after a long battle of fighting so many things. I think with that, we can move to the next question, which is very relevant to the pandemic. It says that there is a lot of fatigue that we're dealing with in the pandemic because of the digital world that we're living in. Everything is online. It is affecting the mental health of a lot of people. How are we supposed to deal with that, especially because it seems like this is here to stay?
Well, Shruti, yes, we have too much to do online and much less to do, like we used to do earlier, going to work, commuting, meeting families, and all of that. And we really need to adjust to that, because that is the reality. And as Neha said earlier, we still need to maintain a social connectedness. So let's not ignore that. Physical distancing is not the same as social distancing. So we need to really pay attention to that. But technology can be used in a variety of ways, constructively and sometimes not so constructively. So let's be careful about that. One thing which is very important is let's not drown ourselves in negative news. So yes, we are working online, we are attending meetings, we're doing all of that, but let's not really look at the news every half an hour, because most of the news is negative, and let's keep fixed timings and fixed duration for doing that. Otherwise, we lead our lives in a lot of negativity. Let's avoid that, because it does impact us. So social media is okay, but too much of news, especially negative news, is not okay. Also, fake media is not okay. So let's be mindful of the fact as to what we are accessing. It's not the amount of time, it's the content of that is important. And if we keep a tab on that, to say we are going to talk to our family and friends and not to 5,000 people who might be disseminating all kinds of news which I don't like. That is important. Of course, sometimes work involves several hours of online work, and that is important. That needs to be done. Let's give ourselves breaks. Let's not continuously do that. And Shruti, I'm especially reminding you because you just went from one session to another one. Give yourself 5 minutes. That's important, really. There was another question attached to that, addiction to social media. Yes, in some cases, especially amongst young people, the gaming as well as social media can become a very serious exercise where you continue to indulge in that and ignore your other responsibilities. You don't eat, you don't sleep, you're constantly on your mobile phone and are accessing social media or even gaming, which is becoming quite common nowadays. I think that is something which one again needs to guard oneself against. There are many rewards in this world from many sources. Let's not confine our rewards just to social media or just to gaming. And especially it's a message for parents. Sometimes young children, adolescents are indulging in too much of that. In fact, WHO last year also gave gaming the status of a disease, just like gambling. So that's a real entity. That's something that we need to guard ourselves against and keep in mind that this can become addictive. Just like alcohol is addicting, gaming can become addictive. And that is something which is increasingly being recognized in many Far Eastern countries in Asia, but also in India. So let's be mindful of that. And some amount of adult supervision on what the child or a young adolescent is accessing online is absolutely necessary. We cannot really disregard that responsibility that is increasingly becoming very important for all of us. Back to you, Shruti.
Right. Let me just take, I can't believe it's been almost an hour already because we've had such a riveting conversation here, and I'm so sure we can go on for hours, you know. It's so heartening to see how many questions we've received. Honestly, I'm very, very surprised, very pleasantly surprised, but very happy with the same. I think the next question that we can take is, how should the family members of a mental health patient deal with the situation, considering most of us are not trained to do so? So I think that would be Neha ma'am, if you could.
Yeah, I think you know, it's the first thing that I would say really is around self-care again, right? Which is to recognize caregiver fatigue and to make sure that we recognize these as family diseases sometimes that have repercussions on everybody. And so it's really important to pace yourself, to manage, to do the self-care that you need to do as you support somebody else. So first things first, as they say, you put the oxygen mask on yourself. So so that's sort of the point number one, right? The second is to really around early intervention, right? And we've talked about this briefly, and to say what is the earliest that you can, if you are in doubt whether this is perhaps just a day-to-day lifestyle problem and it will go away, or it may be something a bit clinical. Most people tend to say, okay, well, let's keep trying to cope with it, and we won't get professional help till it's just reached breaking point, you know. So often what happens is that by the time people go to a healthcare professional for mental health services, it's really at a time of desperation. So I would urge that the second point is really to say, if you see signs of distress, if you see signs where day-to-day productivity, relationships are being hampered, there is no harm in doing even online self-assessments, in doing consultations, in talking to therapists. And it's not about sort of straight away going to a psychiatrist and having medications, but the important thing is that not all psychiatrists prescribe medications on day one. You know, a good psychiatrist will really try and first understand where you are at with your symptoms and what is the extent of the problem, and do you need therapy, do you need medication, what is the best thing, and then proceed forward. So we have a lot of misconceptions also, and some of these misconceptions, to be absolutely honest, have come from the way mental health services have been given, right? There isn't much transparency, there isn't much clarity. People, the professionals don't always tell you what is what, and don't always tell you what the road ahead will look like. So it can be a very confusing journey. So we shouldn't blame ourselves for being lost or not knowing or feeling totally frustrated or frankly ready to absolutely give up, right? But the point is to not try and give up and try and get some support as early as possible. The third thing really is to be able to build a cohort of support, right? And so to be able to look at who else is there in as primary roles, whether it's the school or the college or the workplace. What other awareness can be built within this circle of influence of that person to support them, but also to sort of guide towards treatment, right? And the most important thing is just education, right? How much can we inform ourselves about what it is that we are dealing with? Sometimes the symptoms that somebody presents are not really what they are going through. The clinical diagnosis may be very different. So even somebody who has psychosis will say, I'm feeling stressed. Stress can be just stress, or stress can be psychosis, or stress can be somebody who is suicidal, so it's very important to go beyond, there's that campaign that Deepika has launched about Dobara Pucho, it's very important to go beyond what you see on the surface, and just sort of, focus a little bit more on what is actually going on inside, spend the time to connect. There is a misconception that people think that if you talk about suicidal thoughts, you're actually planting the idea in somebody's mind. It's not like that. In fact, it creates relief when you can talk about it. People who talk about it don't do it as much. And so it's very important to recognize that these are all things that we have, either they're superstitions or they're myths. And the more we educate ourselves, the more confident we will feel about trying to solve for it. Today, 25 years into my mother's treatment, for instance, we see ourselves as a fully rehabilitated family. She's an active grandparent in my daughter's life. She understands her condition, she treats for it, and we are able to live in a harmonious family. And nobody would have imagined that that is even possible, right? So if that's possible for some of the hardest illnesses like schizophrenia and going untreated for many, many years, you can just imagine the hope and the possibility of depression, anxiety, bipolar, and so many other conditions and addictions that can be reversed and that can be brought back into a sort of a normal functioning.
No, 100%, definitely. That was so well said. Definitely given a lot of food for thought for this, for all of us. Just a last few thoughts on the entire panel discussion, because we're now running out of time and have to move on to our next session. So Professor Saxena and Neha ma'am, last few thoughts on this topic.
Well, Shruti, it has been a pleasure to join. A lot of interesting questions. I just wanted to also share two other things very, very briefly. One, we haven't really covered the use of alcohol and drugs. My single message is avoid using them as a stress relieving mechanism because they lead to more problems. So that's important to see. The second is, don't be afraid to talk about mental health issues, just like what you're asking many questions now. Talk to your colleagues, talk to your friends, talk to family members, because all of that can be an extremely enriching and also a very useful exercise. So bring it out of the shadows and not hide it.
Yeah, and from my side, I would just say, be open with yourselves, be accepting, and for those around you. Life is full of possibilities and things can turn around, and helplessness does not mean hopelessness. So there is the hardest is the first step. After that, the journey of mental illness to mental health is actually and surprisingly quite straightforward, and it's much easier. And it creates a lot of hope and possibilities. And so I would encourage everyone to really be more aware and give themselves the self-care and for those around them, particularly in times that are so turbulent. And this is not changing. Realities are going to keep throwing all sorts of challenges our way in the world that we live in today. So it's really important to equip ourselves with the tools and the understanding that we need in order to navigate these turbulent times that are going to be the course of our lifetime. Thank you.
100%. I'd just like you both to know that we've received so many comments on whether this session has been recorded. I just want to tell all our attendees that it has, and it's going to be up on our YouTube channel. So please feel free to head over to the YouTube channel of India Science Festival and do listen to this talk, because it was so enriching and it was such a delight speaking with you both. An absolute honor for us at India Science Festival. Thank you for taking up the time. And I would encourage everybody to head over to the Librem platform. Go to the INRR website. Do have a look at what is up. These are all credible platforms that you can access, and they're there to help us out in times of need. So why not access it? So please do make use of all these resources. And Professor Saxena, Neha, thank you so much for joining us. Such a pleasure.
Thank you, Shruti.
Thank you. All the best.
That was very, very enriching, and such a, I think it was such a personal, up and close personal interaction that we got to have here with Professor Saxena and Neha ma'am. Really, we don't get many platforms like these to address our issues, and I think it was really great to have them with us here today. So why not move on to something a little lighter? We had organized a science fiction writing competition at our festival, and we have shortlisted the finalists of this fest, of this competition at our festival, and the finalists have gotten the chance to speak at our festival. So can I please request the Spin Your Science finalists to turn on their audio and video and join us for their reading session? Looks like our finalist is taking a little more time to join us. That's fine. Till the time our finalist joins us here, so at 8:15 we have a very interesting talk on uncovering the dark secrets of our universe by astrophysicist and cosmologist Priyambada Natarajan. She is going to be telling us a lot about the secrets of the universe that we live in, and she's going to cover topics like black holes, something very interesting, and I think stuff that really interests a lot of us. So that's going to begin in the next 10 minutes, and it was very nice to see the number of questions that we received at this discussion. Can we? So I think our finalist has joined us. So your name has been, just one second.
Hello, Shruti. This is Dilip Tosar. Can you hear me? Am I visible, audible?
Yes, sir. You absolutely are. And we're very ready to hear your science fiction story. Thank you so much for joining in. You were named as another participant, so we couldn't quite access your profile. But please go ahead. The stage is all yours.
Sure. Thank you. I'll begin reading the story. The title is First Contact. Amruta shrugged off the blanket. It was a sultry, hot July morning, but a nightly fever had forced her to wear that warm sack. Her family was concerned about a fever and mild headaches. She had tested positive for the inevitable COVID virus. Having completed few days in quarantine, she had few more to go before she could leave her room. She scowled at her sister, Arushi, who just showed up at her room door with a chirpy "Good morning, Didi," and what would Her Majesty have for her breakfast at coronation? How about some corona flakes? That really blew the lid off Amruta's patience. Why me? She whimpered. Even her early morning dream was about gambling in the garden with flowery corona balls with obscene short trunks that kept popping eyes and ears and mouths. Just what is this thing? Bigger question, why is it? I'm bored dead, Amruta bawled out. Arushi offered to read to her some fascinating articles about SETI, that is Search for Extraterrestrial Intelligence, Anything we knew will do, implored Amruta. Arushi started. It all started with looking for sentient aliens like us. You, monkey, sentient? Antara, their kid sister, broke in with a childlike fascination. With a whack on Antara's posterior, Arushi continued about how the first human message believed, readable by aliens out there, was an electronic broadcast of Hitler's 1936 Olympic speech. Scientists started seriously looking for alien responses to the broadcast. Arushi showed them some pics of Voyager 1, the only man-made artifact to enter deep space beyond the solar system. Antara asked with wide-eyed wonder, so did the aliens see that golden phonograph on the Voyager with lots of data about humans? Did anyone respond? Amruta the elder spoke with her expected protective wise angle. Why did they have to send information about us to the aliens? Now they will know all about us and will come and kill us. Arushi defended the SETI. Come on, girls. Huge telescopes on mountains and the moon were built to sense signals coming from them, hopefully telling us about themselves. Antara wondered, so did either we or aliens find each other yet? Arushi loftily offered, no, BBSs, it's not that simple. See, when we think of intelligent species out there, to communicate with them, we make many assumptions. We discovered electricity and magnetism just a few hundred years ago. So we think electronic communication is the sign of intelligence. Come on, we believe ants are intelligent and baboons and dolphins. But do they know if we are intelligent? If you speak a language I can understand or behave as I do, only then you may seem intelligent to me. It's as much about our understanding their language as theirs. That's why SETI scientists keep sending information about humans in as universal a language as they can. Like we believe it's universally smart to know the Fibonacci series. So if we show them that we know it, they may realize that we are intelligent. But in their beliefs, they may just have some totally different indicators of intelligence too. A Bengali and a Swahili, not knowing each other's language, would not understand what the other guy is saying, or even if he's saying anything at all. Antara let out a yawn. Yeah, this is getting too heavy for a COVID morning, but it reminds me of this nice game I learned the other day. It's called Intro. Let's play it. So Amruta gives Arushi the name of an animal and Arushi makes me guess, just by gesturing with her hands, who that animal is. Arushi should not speak, mouth or write, not even in the air. Amruta nodded. Hey, that's tough, but everyone is too bored, so we might as well play. Amruta gave Arushi iguana as the animal to introduce to Antara. Arushi began with great gusto. She tried showing animal, green, herbivore, reptile, but Antara wouldn't just get it. As they ran out of time, Antara gave up her answer. It's a gobbledygook, yeah. Arushi exasperatedly exclaimed, it's an iguana, Dumbo. Antara, already smarting at having lost the round, shrieked, what's an iguana? I never heard of one. How do you expect me to guess something that I don't even know exists? Arushi stared wisely at the sky. That's how SETI scientists must be feeling, looking for signals from aliens or sending them some. That night, Amruta slept hardly a wink, kept dreaming about aliens, iguanas, and viruses, especially COVID balls whistling through their many pouty protrusions. She thought she saw patterns in the whistles and the geometry of those colorful balls flirting around with her cells. But why do they attach themselves to our body cells? They don't get food from us, so why get into our cells? They're not even really living, let alone be intelligent and scient. Who designed this whole thing about having half-hearted pieces of RNA strands protected by protein sheets puke their pieces into our cells to try and mutate them? The results are good neither for the virus nor for the host. The host is living, the virus is not really living. The virus gets into the host fires it out with antibodies. Both weaken each other. A virus attempts to mutate the host at a genetic level. Finally, one of them and then both die in the process. Why? The viruses keep happening every now and then, from common cold to cancer, playing internecine wars with humans and other animals. Any such useless process should have been kicked out by Darwinian evolution in nature, but hasn't been. So there must be a design backed by an intelligence that keeps it going. What is this design? Who is running it? Amruta knew that what she would be doing the next day, and promptly she slipped into a delirious slumber, dreaming about aliens, iguanas, viruses, and Arushi, all spinning thoughtlessly in her mind, like in a washing machine. Next morning, head still spinning, Amruta bawled out, Mom, Give me access to your office account now. Dr. Mrs. Lata was a renowned senior grade F scientist at the International Institute of Virology. Nowadays, like everyone else around, she too worked from home with remote secure connections to her office computers on the internet. Lata obviously refused Antara that privilege. Even thinking about doing it would be sacrilege. Besides, today she had online meetings planned through the day. Strangely enough, for that whole afternoon, Dr. Lata ma'am simultaneously spoke in the meetings and also was very actively logged into her main computer account, accessing and processing petabytes of data from her dry and also wet labs through the Institute Cloud, free student accounts on AWS and GitHub, pouring results into a laptop, which could be tracked to the residence of Dr. Lata herself. Amruta was deliriously hammering in code, seeking patterns in the RNA structures, in geometric and visual structures of virions, of numerous strains of COVID-19 virus. One pattern stood out. The hex code of the longest RNA string in every virion hashed with a combination of Blake and City hash functions to exactly 712. Amruta also observed another combination of the hash, maintained one part of the string constant, mapping onto itself. This string kept referring its own value as its hash. Amruta's feverish brain saw the vision of a giant iguana, acting out the word iguana to Antara. The fellow kept pointing to its own self, but Antara couldn't identify it as she didn't know anything about it. Amruta ran the same program on the previous virus, the SARS virus. The self-introduction string was identical to that of COVID, but the first hash led to 710 instead of 712 in COVID. Amruta collapsed in exhaustion. Sometime the next day, Amruta opened her eyes to see Arushi poring over her with a worried face. Amruta blurted out, "Arushi, you know what? The virus is a message, I guess from aliens. Its appearance, behavior, everything is encoded in RNA strands, much like our DNA. Why RNA? So both they and we could understand it. Their identity is encoded into an RNA code describing itself. These constructs repair themselves on damage, a self-correcting message. It actively finds DNA-based life forms that will understand it and then imposes itself on them to be read. Such messages must have come across millennia possibly. The COVID is the 712th broadcast and SARS was the 710th. Arushi's mind whirred at a zillion RPM trying to figure that out. Oh my God, she gasped. And so what is the message, Amruta? Amruta collapsed in a delirium, muttering incoherently, "Hello." A self-intro, a sonorous H-E-L-L-O, hello, kept haunting Arushi's head since that time. There's got to be more than just a hello. Should they say hello back? How should she? Shouldn't she first find out the full message and who sent it? She promised herself that she definitely would. Just wait, you viral messenger. We have seen your handshake and are coming to check you out now.
Thank you so much, Sithosa. That was really lovely. I think you have written a lovely science fiction story for us. And, congratulations for making it till the final round of our science fiction writing competition. We are now going to move on to our very exciting talk for the evening. May I please request Professor Priyamvada Natarajan to switch on her video. Good evening, ma'am. Thank you so much for joining us. Such a pleasure to have you at India Science Festival. It's a pity we couldn't have you flying at at a festival on ground, but nevertheless, so excited to have you at the virtual edition of our festival. Thank you for taking out the time.
Yep. Thank you very much for inviting me. I'm really excited to share some fun new science results about mysterious components in the universe.
I'd like all our attendees to know that Professor Natarajan is a professor in the Department of Astronomy and Physics at Yale University, and she is very well known for her work in mapping dark matter and dark energy and in her research with black holes. So we're super excited to listen to you, ma'am, and I'd like all our attendees to know that post the session, we will be doing a quick 10 to 15-minute interaction with Professor Natarajan. So those of you who are interested in asking her a few questions, make sure you stick around till the end. Ma'am, thank you so much for joining us. Over to you.
Thank you. Hi, everyone. I'm really excited to virtually meet you all and share some exciting dark secrets of our universe. So I will be talking today about two components of our universe that are invisible and have remained elusive, but yet we have learned a lot about them and their true nature recently, as well as their significance in terms of what they do cosmologically, how they impact the formation of galaxies and everything that we see that is actually visible. So as we'll see, these two invisible components actually structure everything that we actually end up seeing in the universe. So first of all, I want to start by giving you a quick timeline of the history of the universe, starting from the Big Bang. And I just want to let you know that this is a timeline that we understand quite well because we have snapshots, if you will, from various epochs in the universe that have given us the data, so direct data from the early epochs of the universe, not from the Big Bang and inflation directly, but everything forward from the cosmic microwave background, which is sort of the relic radiation from the Big Bang. So we now know that the age of the universe is roughly 13.8 billion years, and we know the sequence of events. So we know that the universe started out in a very hot, dense state, and that very, very early on, during a fraction of a second after this Big Bang, which is essentially the definition of time equals 0, the universe expanded exponentially. And then it was filled with this hot relic radiation, the cosmic microwave background radiation, which is what we detect directly. So this is from about 400,000 years after the Big Bang. And this is radiation that we detect. So this radiation has been streaming towards us as the universe has been expanding all the time during this time. Then we also know when the first stars form, it's about 200 million years or so after the Big Bang. And then from then on, we know how all the galaxies and the other structures we see in the universe assemble. So this is extremely well understood at this point. Obviously, there are many details. As I mentioned earlier, for example, we do not know why we have the initial conditions that we have in the universe, why we have this particular form of inflation, and so on. But you'll see that one of the things that we do know extremely well from many independent lines of evidence, observational data, is the composition of the universe. And what we know is the composition of our universe is really rather peculiar. So the bulk of the universe comprises a mysterious quantity called dark energy. And all the matter in the universe that we know and that we are familiar with, which are referred to as ordinary atoms or baryon, they are just a mere 4% of the overall inventory of the universe. And the bulk of the rest of the matter is a peculiar form of matter that is called dark matter. It's obviously called dark matter because it does not interact with light, which means it is not visible using any wavelength of light. But it is made, we believe, of some early particles that were created in the very young universe. And as you can see from this pie chart, this green component, dark matter, forms the bulk of the matter distribution. And there are many interesting ways to infer the presence of this dark matter. So one method that has been particularly effective is what I'll be talking about today, and that is the bending of light. So this is a phenomenon that is predicted by Einstein's theory of general relativity. So as you all probably know, Newton's theory of gravitation was completely upended by Einstein's reformulation and reconceptualization of gravity. So you're all familiar that Newton told us that gravity is the force of attraction between any two objects of mass, m1 and m2, and it's proportional, the strength of that force, which is attractive, is proportional to the product of the masses and falls off as the distance between them squared. So it turns out that Newton told us what gravity, how gravity behaves, but not what its nature is. And that's what Einstein did, which is fundamentally change our understanding. So in Einstein's view, gravity is the interaction between matter and space-time. And space-time is this four-dimensional sheet, which has 3 dimensions of space and 1 of time. And this is a sheet in which we are all embedded. There's nothing above the sheet, there's nothing below the sheet. So all galaxies, everything in the known universe are objects that are embedded in the space-time. And the property of matter, this interplay between space-time and matter, is that the presence of matter causes little potholes in space-time. So you can imagine that the universe is actually this sheet that is pockmarked. So every time any mass, so the sun, a little asteroid, a big galaxy, clusters of galaxies like I am showing in the schematic, all these cosmic objects create a huge pothole in space-time. So for example, one consequence of that is that light, as it travels through the universe, because remember the universe is this sheet, will go up and down, traverse every pothole, and it will carry the imprint of having traversed each of these potholes, much like our cars that face all the potholes on the roads that we drive. So for example, gravitational lensing is the bending of light. And so this is the effect that is a consequence of the sort of 4-dimensional space-time and are being embedded in it. So light from distant galaxies, as shown here, will arrive to us on Earth. And if you have an intervening object, like I've shown here, which is a galaxy cluster, so these are very massive objects in the universe. They are aggregates of about 1,000 galaxies that are held together, it turns out, by a huge amount of dark matter. So it's the dark matter that you don't see that dominates the mass inventory of this particular object that causes a very dramatic deflection of light. And the way this manifests is that the shape of the distant galaxy that you are viewing through this intervening lens, light is bent, and the consequence is that you no longer see the original shape of that distant galaxy, you see it completely distorted and bent. So here's an example, but in this instance, the lens, unlike here, which was a cluster of galaxies, a conglomeration of galaxies, here it's an individual galaxy. And so you can see in this panel on the right, this is a Hubble Space Telescope image. So this is a real image. And what we can do, the analysis that we do, you see this highly distorted blue shape, this arc. And in effect, in reality, that is actually a fuzzy little blue galaxy, but it just happens to line up behind a lens, an individual galaxy that mangles it and distorts it. So what we can actually do by looking at the level of distortion, we can actually work out how much matter there is in between us and this distant galaxy. So that allows us to map all the matter, so both visible and dark. And as I mentioned, the proportion of dark matter really supersedes that of the visible matter. So in effect, you're actually mapping dark matter. And so this gravitational lensing effect does one other interesting thing. In addition to distorting the shapes, it actually magnifies objects distant. This is why it's called a lens. It magnifies objects, and occasionally, if things line up just right, you end up producing multiple copies of the same object. So here's an example of a Hubble Space Telescope image where you've produced 5 copies actually, and I've marked out 4, and I leave it to you to figure out where the 5th is. If you look carefully in this image, right at the center, you'll see that there is this 5th image that shows up. So these are actually all images of the same object. In reality, there's only one object. And how do we know they are the same object? Because we can go and take spectra of each of these objects and they are identical, what is seen. So here's another cluster of galaxies, a Hubble Space Telescope image. And in this, you can clearly see the lensing effect. You can see these distorted shapes, these arcs and arclets that are framing. So the yellow fuzzy galaxies that you see, they are galaxies in the lens. The blue and the orangish arc that you see here are the distorted shapes of background galaxies. So we can use that image, and with methodology that me and many others have developed over the years, we can actually reproduce the features of the lens, the mass distribution of the lens that is actually producing the distortions that you see. And so what you find then, this is a topographic map, a cartographic map of how dark matter is distributed in this cluster of galaxies. So it is piled up, you can see, and when lots of little clumps, so it's very, very clumpy, and we can make a real detailed map of the contours of how dark matter, how granular dark matter is in these clusters of galaxies. So here's another recent image from very, very deep look at the universe from the Hubble Space Telescope again. It's another cluster of galaxies. And what you see in the image on the left is what Hubble actually sees. And on the right-hand side, you can see in the fuzzy blue, we have reconstructed from the observed distortions, the detailed distribution of dark matter. And what I've shown here in the middle panel is a reconstruction of the dark matter distribution rendered as a landscape. So you can see all the clumps, the hills and the valleys. And what is shown here is one of the most detailed distribution, spatial distribution of dark matter in this object. So we don't know the nature of dark matter. We just know that it is, it does not interact with light, that it is dark. But we also know that it forms the scaffolding of the formation of all structure in the universe. So dark matter offers the scaffolding in which you actually form the galaxies and the visible stuff that we see. So what I'm showing you here is a simulation of our theoretical model for the understanding of dark matter. And it's mocked up to look like light, but it's actually all just dark matter. There's no light. It's a dark matter only simulation. This is just to visually show you some peculiar properties of dark matter. One of them is that it interacts only via gravitation and that it's collisionless. So if you have two dark matter particles, they don't actually collide and stick with each other. They just graze past each other. So what you can see here is the dark matter distribution is very, very clumpy if we assume that this dark matter is collisionless, and this kind of dark matter is called cold dark matter. And we believe that that is the best description for the dark matter in the universe. What you see here are two panels where if we change the nature of dark matter, it reflects immediately in the clumpiness of dark matter. So on the right-hand side, you see another kind of dark matter called warm dark matter. And on the left-hand side, we see this cold dark matter that we just saw the simulation of. So from the reconstruction from gravitational lensing, from the reconstruction of the clumpiness of that detailed landscape that we saw, we can actually determine and get a clue to the nature of dark matter. And so at the moment, so our latest results suggest that these are the peculiar properties of dark matter and that it is consistent with dark matter being cold dark matter. You might say, okay, what do you mean by cold dark matter? Then there are actually particles that are available in the early universe. And in particular, there are two kinds of particles that are potential candidates for dark matter, axions and WIMPs. WIMPs are just weakly interacting massive particles. So that's where we are with dark matter. So let me now move on to the next elusive component of the universe, mysterious and enigmatic, and that is black holes. And so what I want to quickly share with you is our understanding of where we are, what's the state of the art in terms of understanding how black holes form and grow and evolve. So coming back to Einstein's theory of general relativity, you may remember, I just told you that Einstein's theory reformulates this relationship between matter and space. And one important feature is these, remember those potholes. So the presence of matter causes this change in shape of space-time. So if you have no matter in the universe, then space-time would be completely flat. So for example, this is a cartoon to give you a feel for what's going on. So the sun, for example, makes this kind of pothole that you can see that's visualized here. And a neutron star, by comparison, which is a very dense object, very compact and dense object, notice the very deep pothole that a neutron star makes. So now to give you a feel for what a black hole really does is that you can think of the black hole as making a puncture in space-time. So black holes are extremely dense, very compact, and this is how they actually change the shape of space-time right around them. So the three black holes are kind of complicated objects, as we'll see in many ways, but they produce very enigmatic sort of effects around them. And so let me tell you a little bit about three different ways to think about black holes. So one, we can think of black holes in terms of the strength of the pull of gravity. We just saw that they are very compact and very dense and transform the shape of space-time fundamentally. So you can think about a black hole as you can think of it as a material object, if you will, whose gravity is so intense that nothing can escape from it. So how does that work? So as you all know, to leave Earth's atmosphere and the gravity exerted by Earth, you have to boost rockets because to leave and escape the gravitational attraction of the Earth. And for the Earth, the escape speed from the gravitational grip of the Earth is about 11.2 kilometers per second. And that's why we need rockets and boosters to actually launch spacecraft, and as you know. So what if, just imagine if the escape velocity was actually the speed of light. And that is what we have for black holes. And that's why black holes are black. They do not emit any light, and any light that reaches close to them actually cannot escape. So black holes are also the dense corpses, the end state of massive stars that form in the universe. So they are a feature in the natural life cycle of stars that form in the universe. So the very massive stars, not stars like our sun, stars that are about 10 times more massive than our sun, will end up and leave behind, will end their life cycle, become a bloated red supergiant, then will go supernova, will explode, and then leave behind a black hole. So you can think of them as either objects that have intense gravity, the end state, the compact end state of a massive star, or as we saw, the punctures in space-time. So what do we know about black holes at the moment? We now know, this is a real image. We are starting out from a real image of a nearby galaxy. And now we have an artist's rendition as we are following right into the heart of this galaxy. And what we know is almost every galaxy in the universe harbors a black hole in its center. And we know that this black hole is fed by gas, which is rendered here in this artist's impression in red. It is fed gas, and this gas makes its way to is pulled by the gravitational attraction of the black hole, and en route it gets heated up, it starts glowing. So what you end up seeing are the dying gasps of matter as it falls into a black hole. Not the black hole itself, but the matter that is on its way to the black hole to a point of no return. Because remember, not even light, once captured by a black hole, is emitted out again. So these black holes that inhabit the centers of most galaxies, we know, are sort of in two states. They're either fasting or they're feasting. They are fasting when there is not much gas around and they're not feeding, like the black hole at the center of the Milky Way. So this is an image that I'm showing you from one of the Nobel Prize winning astronomers who was awarded the Nobel Prize for her work on studying the properties of black hole in the center of our galaxy, Andrea Ghez. So this is an image. So this is a black hole that is really not feeding, it's fasting. Meanwhile, there are other black holes that are feeding, and these are what we call quasars in the universe. And quasars are the brightest beacons in the universe. We see them out to the farthest reaches. So how did the first black holes come to be? And I just finished telling you that they are the end states of stars. It turns out, and the first generation of stars, how did the first black hole ever form in the universe? We believe it came out of likely the first star that formed in the universe that was massive, and as I told you, leaves a black hole as a remnant. But there are in fact many other ways. We now know of a lot of other ways of making the first black hole seeds. And this is where a lot of my own work has focused more recently. And that is alternate ways to make black holes. So one, you could make a cluster of stars in the early universe. They could all leave little black holes that could merge and make a bigger black hole seed. Or you could make black holes from the direct collapse of gas without forming a star. And you make these very massive black hole seeds. And we believe that's another channel. So how do black holes actually grow? As I mentioned, gas flows in, it's held in a disk, and it peters in from the disk onto the black hole. And so this process is called accretion. We also know that accretion is triggered in the universe because of a natural way in which galaxies build up. So galaxies in the universe build up hierarchically. So you form the small galaxies first, and then they crash into or merge with each other to make bigger galaxies. So if you have two galaxies that harbor central black holes, when the galaxies merge, remember their dark matter will not collide. It will just graze past each other. The stars will collide, and the black holes will actually get captured, and they will eventually collide. So what you are seeing here in the middle panel is a simulation from one of my former graduate students. You have two spiral galaxies, each of which is harboring a black hole in its center, which you can see flickering because it's feeding. And then eventually, when these two galaxies have crash landed into each other, the black holes merge, and you end up with one bigger black hole. And in the panel on the right, I give you a top view of a zoomed in top view of what's happening in the heart of that merger. It's a very violent merger. And what we are seeing is the top view where you have one black hole that's sitting in the center, and a second one is just plopping in as it's delivered by this merger. And you can see it slowly spiraling in. And as it spirals in, you start seeing some features. If there is gas, there will be gas around that will glow. And these are predictions that have been made for something that should be detectable very soon with the next generation of space missions. So when the black holes finally merge, because remember, they are punctures in space-time, they are sort of pulling space-time along, they are dragging space-time along, and they produce what are called gravitational waves. So the gravitational waves, you may have noticed from the collision of two stars has been detected already by the LIGO collaboration. This was reported a few years ago. And so these are supermassive black holes. These are black holes that are about 1 million times the mass of the sun, that are sitting in the centers of galaxies. Their collisions have not yet been detected, but we have plans to do so. So gravitational waves from supermassive colliding black holes should be detectable with a planned mission called LISA. And this is a US-European mission, which should fly in the 2030s and should detect these gravitational waves. So I stop here with sort of a bird's eye view, a quick view of what's really going on with the dark secrets of the universe and how much we have unraveled. Thank you so much for your attention.
Thank you so much, Professor. It's black holes and the elusive contents of the universe are something that have fascinated most of us for a large part of our lives. And it's been fascinating to get to know more about it directly from an expert.
Thank you so much.
We have a large number of questions that have been coming in through the webinar as well as our other social media channels. So I'll be taking a few of them right now.
Yeah, please go ahead. Yeah.
But just before I do that, I want to announce that at the end of this session, in another 15 to 16 minutes, we will be having a closed short interaction with Professor Natarajan in a private meeting room, the link to which will be put in the chat as we wrap up this session. Meanwhile, thank you so much for taking time out to answer our questions. And one question that seems to be fascinating everybody is that what happens to the material that does fall into a feasting black hole? Does it get destroyed? Does it exit into another universe? What do we predict?
Yeah, so we do not precisely know, because the nature of a black hole is that black holes have this boundary called the event horizon. So this is a region around this puncture, and once matter passes past this horizon, we actually can never get any information about it. So we believe that what happens is that this matter is destroyed once it gets into a black hole, and it gets, so the mass of the black hole changes, right? So that's how black holes grow. So you can think of it as the black hole being a reservoir where this matter goes in. However, it is not quite as simple as that, because the precise physics, we have an understanding, but not observational data past the event horizon. So the speculation is that, you might ask, so where if matter falls in, there's a puncture, where does it go? It's not so much where matter goes, but this puncture in space-time, we believe, could actually lead you to potentially another universe, or to tunnel. It takes you elsewhere, which is not part of our universe. So that's a speculation. We do not have any data. So this is one of the reasons black holes are so intriguing. They have this boundary called the event horizon. But as I mentioned, what we do know is that we believe this is how the masses of black holes grow. So the size of the event horizon of a black hole is directly proportional to the mass of the black hole. So when matter falls in and crosses the event horizon actually grows for a black hole because the mass goes up.
See, this is truly the stuff of science fiction, and it's perhaps made more interesting because this is something that's not fiction and does exist in real life.
Absolutely, because we see these feasting black holes, quasars, they're seen. They're like the lighthouses of the universe. They're sort of scattered. We see them out to great distances. So we know that the energy is released and this matter is actually crossing the event horizon.
I see. Another question that we have received multiple times from the audience members talks about dark energy. So you mentioned that we can visualize, perhaps not see, but visualize dark matter. But as a consequence to that, should there also be dark energy? And do we know anything about it?
Right. So as I mentioned, one of the key dominant components of our universe is dark energy. Again, it's one of those entities, mysterious entities in the universe. We know what it does. We don't know what it is. So just as we know for dark matter, we know that dark matter provides the gravitational glue to hold everything. And I showed you that, black holes sit in the centers of galaxies and they shape galaxies. So dark energy, we believe, is what powers the accelerating expansion of our universe. So that's what we know about dark energy at the moment. We believe at the moment that corresponds to like energy of the vacuum of, you can think of it, I don't know, those of you who've studied chemistry would know that the hydrogen atom has a ground state. So the ground state does not have a zero energy, it has some positive energy. So we believe that the ground state of the universe, this dark energy could be providing that. This is a hypothesis at the moment and it's being tested. We know that dark energy exists and that it powers the accelerating expansion, but how it came to very early on in the universe, its origin, whether it changes with time, et cetera, we do not actually know at the moment. So that's the cutting edge in terms of cosmological observations and looking for evidence for, variations in dark energy and so on.
I see. And a general recurring theme in these questions seems to be, and your answers, seems to be that we are still testing for these theories. Another question that comes from the audience is, how many of our theories about the ancient universe, or even what makes our universe today, are actually testable, and how many of them can just be left as theoretical formulae?
Or let me clarify. Everything that I've talked about today is observationally extremely well supported, and there's incontrovertible evidence. So, the inventory, what these entities do, etc. This is not just a theory. This is the theory. But remember, science inherently is provisional. What we know is best to date. That depends on the data that our best instruments can take today. So tomorrow, when we have better instruments, we have more data, better quality data, our picture and our understanding gets refined. It rarely happens that we completely overthrow a current understanding and you have a brand new understanding. That happens very rarely. What really happens in science is that there is continual refinement as we learn more and we learn more deeply. So for example, as I mentioned, we have direct observational data from when the universe was 400,000 years old. So we have everything that I've told you about the sequence of events, the properties, the constituents. We have direct data, imaging data from, we can go and look back out to 400,000 years. The only time for which we do not have the data is inflation. So that is, the early sort of 10 to the minus 23 seconds after the Big Bang. So from that epoch of the universe, we do not have direct data. But we are always improving. There are many open problems because we are building more and more sophisticated instruments and getting better data. So for those of you young people out there looking for areas that you want to maybe do research in, cosmology and astrophysics are fantastic. So, and they have lots of open, exciting problems. But we have a very solid understanding, so of this theoretical understanding in cosmology. So we have this concordance model, cosmological model called the concordance model, that is very well supported by data.
I see. And another question that's been recurring from our audience is that all of these observations and data, do they give you predictive powers? Is there a way to predict how many black holes there will be in a given galaxy, or what will be their size or their effect on the galaxy?
Yes, absolutely. And that is why these models are so compelling, and that's the kind of work that I do, which is build these models, use data to constrain these models, and allow, and this permits the models to actually make very, very key testable future predictions for what other things you should detect. So for example, one of the predictions of the model the framework in which black holes fit in the centers of galaxies and so on are predictions for how the properties of the galaxies that host these black holes, how they should be correlated to properties of the black hole, because a black hole is clearly assembling in the centers of these galaxies, just where the stars are assembling. So there are many, many concrete predictions you can make from this model. And this cold dark matter model is actually extremely successful and has been very well tested on many scales. Are there tensions? Do all the observations and the predictions agree with the model? It turns out there are some intriguing tensions that have shown up. And actually one of them that pertains to the granularity, this clumpiness of dark matter that I mentioned today. And we actually, if anyone's interested, we had a recent paper in Science published last September in which we talk about this. So, we have a very well-established model, but we're constantly prodding and testing it, stress testing it to see if the predictions and the actual theoretical model actually match. The predictions as in predictions made from the model and observations that we make of the universe, whether they really mesh together or not.
And Ma'am, you mentioned clumpiness of this dark matter, right? Another question that's been coming in is you mentioned during the course of your talk, you mentioned that dark matter doesn't stick to each other.
Yeah.
So if it doesn't have any stickiness, how is dark matter clumping in the universe?
So dark matter is clumping only because of gravity. So, it doesn't have charge. So it doesn't clump because there are electrical forces. The only force that dark matter particles feel is gravity. So they eventually clump because of gravity, because of the attractive force of gravity, but they do not feel any other forces. And when I say they're collisionless, so the way to think about it is that, they don't have pressure. So many of you might have heard of Boyle's law, which is, the relationship between the pressure and the volume and the temperature of a gas. So basically, why do you have pressure? You have pressure because gas molecules collide with each other and they collide with the container. So that's why you have pressure. So dark matter particles, if I put dark matter particles, they don't actually collide with each other. And so they will not actually have pressure. So they have this peculiar equation of state. So, Boyle's law describes equations of state. And the equation of state for dark matter is P equals 0, pressure equals 0. So it's a very peculiar sort of behavior. And it has gravity, but it has no pressure.
I see. There has been another question about supermassive black hole mergers, which asks that why have we not detected them yet? Is it a sensitivity issue, and can LISA help? Or have we just not run across such mergers happening before?
Oh, no. Everything has to do with our instruments, as I keep saying, right? So these supermassive black hole mergers will produce gravitational waves at much lower frequency than our current detectors are able to detect from the ground. So the LIGO project that detected gravitational waves from colliding stars was based on ground detectors. Remember, India is part of advanced LIGO as well. So these are detectors based on the ground. For supermassive black holes, their collisions are in fact very frequent in the universe. We are yet to detect them because the gravitational waves are much lower frequency, for which the detector actually has to be in space. And it has to be off the ground, away from a lot of the disturbances in the atmosphere and other distortions. And so the LISA project has been designed in order to put a configuration of 3 satellites that are going to be launched, as I mentioned, in the 2030s to detect these gravitational waves. And another exciting thing about, there are 2 interesting and very exciting things about gravitational waves from supermassive black holes in contrast to stellar mass black holes. One is because the collisions of supermassive black holes, as we saw in that simulation, occur in the context of collisions of galaxies a little bit before they actually have the final merger. You will see some, as you saw in the simulation, you are likely to see some fireworks beforehand. So you get a clue to where it might be happening, where these gravitational waves might come from. So, the directionality of where the merger is happening. And because it's happening in sort of the messy parts of galaxies, you'll see a precursor in other wavelengths. So, gravitational waves are not like electromagnetic radiation, right? They're fundamentally, they are waves in space-time itself. They are tremors in the fabric of space-time. Whereas with stellar mass black hole mergers, unless it's 2 neutron stars, if it's just 2 black holes, you don't see any other electromagnetic radiation. You just get the gravitational waves. For supermassive black holes, we are likely to see fireworks before and after that will be detectable in the radio, in the optical, in the infrared. So there's a very rich set of data that we're going to get for every supermassive black hole merger. I mean, I'm really, really excited by that. And, I actually serve on the NASA LISA science team. We're trying to make predictions for what all this new set of instruments should see. And it looks really exciting.
That's amazing. I'm sure all of our audience members are also going to tune in to see what comes out of these exciting collaborative ventures.
Yeah.
So thank you
Just
so
want
much.
to close and mention that there are young people want to do exciting science, do astrophysics.
Thank you so much for taking your time out and spending time with us in India Science Fest. The link for the private chat is now, the private meeting room is now in the chat. And I hope to see you in the meeting room for a smaller, closer interaction with Professor Natarajan. Thank you, Professor, so much for agreeing to do this.
Thanks, everyone, and see you in the chat room briefly in a moment. Yeah, bye.
Thank you so much, Professor. Thanks a lot.
So I should just leave this Zoom room and get into the other one?
Yes, the second link. Yeah. Right, that was a very interesting interaction with Professor Priyamvada Natarajan on astrophysics and cosmology. Discussed some really cool things regarding black matter, black holes, and dark energy. So I think that was very, very interesting. And from one interesting session, we move on to yet another one. It is an absolute honor that I get to welcome Professor Ken Ono, Professor Rob.
We're just waiting for Professor Natarajan to join us.
Professor Ken Ono, Professor Kanigal, and moderator for today, Shubhashri Desikan from The Hindu. We are going to have a very interesting discussion today on the representation of STEM.
Professor, can you...
is there a...
Hello, Professor. You should be able to unmute yourself now. And thank you so much for joining us in this closed room session. We have a few participants who have joined in from the main meeting. And I request all of you to put your questions or Professor in the chat. And then our moderator, Abhijit, who's also here, will be picking up questions from the chat and asking people to unmute themselves and directly speak with Professor Natarajan. I'd like to introduce our moderator, Abhijit, to you. Who also has the first question.
Yeah, thanks a lot, Nisha, and thank you, Prof, for the wonderful talk. I have sort of a general question, and it stems from the fact.
Perfect. Now, as we know, what's a Zoom session without a technical glitch? I'm back, and we had a bit of a cross connection there, but it's sorted now. I am again getting to welcome Professor Ken Ono, Professor Robert Kanigal, and Shubhashri Desikan from The Hindu, who are going to be in discussion about the representation of STEM in cinema and literature. Our moderator for today, Shubha ma'am, is a journalist with The Hindu. She's the senior assistant editor, has done her PhD in condensed matter herself, and is now a full-time journalist. And it's such an honor to have you with us today, ma'am. Over to you. Let's get this discussion started.
Thank you so much, Shruti, for the kind introduction. Greetings to all present here. It's a great pleasure to participate in this panel discussion on the man who knew infinity and representation of science and maths in literature and cinema. We have with us two excellent guests here today, Professor Ken Ono and Professor Robert Kanigal. Professor Robert Kanigal is the author of 8 previous books. Most recently, Eyes on the Street, The Life of Jane Jacobs. He has received many awards, including a Guggenheim Fellowship and America's National Endowment for the Humanities Public Scholar Award for his upcoming book, Hearing Homer's Song, The Brief Life and Big Ideas of Milman Parry, about a classical scholar who has overturned prevailing ideas about the creation of the Iliad and the Odyssey. Professor Kanigal's book, The Man Who Knew Infinity, was a finalist for the National Book Critics Circle Award and the Los Angeles Times Book Prize. It has been translated into more than a dozen languages, and it was the basis of the film by the same name, directed by Matt Brown and starring Jeremy Irons and Dave Patel. Professor Kanigal is Professor Emeritus of Science Writing at MIT, and he lives in Baltimore with his wife, the poet S.B. Merrow. Welcome, Professor
I'm
Kanigal.
delighted to be here. Can you hear me?
Yes, very well. Thank you.
Good. Thank you.
Thank you. Professor Ken Ono is the Thomas Jefferson Professor of Mathematics at the University of Virginia, and he's also the Vice President of the American Mathematical Society. He specializes in number theory, especially in the fields of interest to Srinivasa Ramanujan, such as integer partitions, modular forms, umbral moonshine, and so on. He received his BA from the University of Chicago in 1989 and earned his PhD in 1993 from the UCLA. Professor Ono has received many awards for his research. In April 2000, he received the Presidential Career Award from Bill Clinton in a ceremony held at the White House. In June 2005, he received the National Science Foundation Director's Distinguished Teaching Scholar Award at the National Academy of Science. He has won the Sloan Fellowship, Packard Fellowship, and a Guggenheim Fellowship. In 2019, Professor Ono was also the Jubilee Distinguished Professor of the Indian Academy of Sciences. He was an associate producer and mathematical consultant for the movie The Man Who Knew Infinity, based on the biography of Ramanujan by the same name, authored by Professor Kanigal. It's a very pleasant evening, and I welcome Professor Ono to the show.
Happy to be here.
Hi. So can we start with the discussion now? I would like to ask a question of Professor Kanigal first. What is the process behind writing a scientist's biography? What sort of research is needed for this process, Professor Kanigal?
I'm not sure the word process is the best word. Process, I think, conjures up a 1, 2, 3, 4 kind of process that goes in a methodical way, one step following another. And I guess I would say it's not really like that, that you're approaching it on many fronts at one time. Research in general is, I think of as everything you do in order to write, to equip your brain to be in a position to write. And that requires obviously a lot of reading, but also talking to people and going to places, going to sites that figure into your story, talking with experts, constantly quizzing yourself. Do I really understand this? And if I don't understand this, how can I get to the point where I do understand it in a way that I can explain to ordinary readers? The kind of writing I do, which comes under the general heading of science writing, means specifically writing for general readers, people who are not experts themselves and who don't need to know for functional reasons what you're telling them. So part of your job is to entice them, to get them interested in what you're writing about. And that requires knowing much more than you'll end up using. We've all heard the term film left on the cutting room floor. I guess they don't have cutting room floors anymore in filmmaking, but the idea remains that you're gathering much, much more than you think you need in order to be able to pick just the right anecdote, tell just the right story, offer just the best explanation to make something clear.
In particular, in Man Who Knew Infinity, you're dealing with this difficult subject of mathematics. And can you apply what you just said about making it accessible and engaging for the person who doesn't need it in this context?
Sure. Well, I had some background in mathematics, calculus and complex variables and differential equations, but nowhere near the kind of mathematics that Ramanujan advanced. And when I thought I understood something, I would try to reduce it to the to a way that I thought readers could understand. For example, when I'm talking about an integral, I think I used the example of cutting up a hot dog into fine slices. And yeah, you could cut it up into half a dozen slices or 100 slices or 1,000,000 slices, and the slices would be very thin. But if you kept on doing this, in principle, you would wind up with a full hot dog of a number of very thin slices. So that was one attempt. But sometimes I convince myself in the writing that I was being clearer than I was, and then I would try it on someone. In particular, I remember my sister asking Rochelle, "Do you understand this?" And she came back half an hour later, said, "Rob, I don't get this." And I would say, well, what's there not to understand? It's perfectly clear. But the real test is not whether I think it's clear, it's whether the reader thinks it's. So I had to go back and try to break that down into a way that I thought would be clearer for my readers.
Thank you, Professor Kanigal. The next question is for Professor Ken Ono. Ramanujan is known for his deep intuition. How important is intuition in the field of mathematics, Professor Ono?
Well, one can be an important and successful mathematician in many different ways. So there are those who are whip fast problem solvers. There are those people who develop general theory. There are others who learn theories and are able to apply and adapt them to other settings. So the question of how important intuition is to mathematics and to individual mathematicians really varies from person to person. As for the field of mathematics and for all sciences, from time to time, we really do need exceptional and extraordinary people with exceptional intuition that leads to ideas and theorems and conjectures that propel entire fields forward. This is rare. And in Ramanujan, you had someone who was not a professional. He was an amateur by every measure, who, by whatever reason you may believe in, was able to record bizarre, quirky formulas, which often ended up being glimpses of theories that would be developed decades after his life. And that still continues to this day. So in the case of Ramanujan, whatever his intuition was that led him to these formulas that people are still trying to prove 100 years later, for Ramanujan and his legacy, that was very important.
Thank you.
Ken, would it be fair to remind our readers, our listeners, that while he brought these remarkable powers of intuition to his work, he also followed that up with the day-to-day gritty grinding through his work at home?
Yes. Oh, yes. Yes, intuition is, it's not just a collection of a few light bulb moments, right? As Robert says, you know, Ramanujan was well known for scribbling on a slate, looking for patterns, looking for formulas. And so it's a combination, as Robert says, of hard work, which combined with intuition somehow led to all the formulas that we still talk about in his notebooks. It's not just a light bulb moment. They're not just messages that somehow land in his brain.
Professor Kanigal, can you tell us about the cross-cultural aspects that were involved when you were writing The Man Who Knew Infinity?
I had been to India once before on a writing project. I think it was for the National Science Foundation. This was very different because on the first trip, I had a big pocketbook, courtesy of the NSF, and here I had practically nothing. So I was going through to the places that Ramanujan figured in Ramanujan's life, and didn't have much money and stayed in very simple places. So this was certainly an education for me, and it was important that I do that. If you're talking, I think you don't want to stop with India. I found England as much different in different ways from America, from the America that I was used to, than India. I felt probably more at home in India than I did in England. And also, if you view culture in a broader way, there's also different cultures that take place in time. So I was working on the book from 1988 to 1991. And I was writing about a period, let's say 1900 to 1920, call it 1910. And you're working across those 75 years. They do things differently then. I forget somebody said that. The past is a foreign country. They do things differently then. And that's very true. And I had to acclimate to the other aspects of cross culture. And then, of course, there was mathematics itself, and not just mathematics generally, but mathematical research, pure number theory, which was completely different from any mathematics that I'd been exposed to. So you take all these together, India versus America, England versus America, 1910 versus 1988. And I felt that I was working across a vast gulf that I was trying to bring to my readers of what was then the present day. Interestingly, now in 2021, it's about, I guess, a third of the way back to Ramanujan's time since I was working on the book. So there's another gap, another cross-cultural gap, because 1988 is different from now.
That sounds like quite a struggle you would have had. I really admire you for going through that and giving us this wonderful book. There's also the challenge of adapting a science biography to a silver screen. Professor Ono, how easy or difficult was it to do that in the film?
So that's a great question. I have to say, as a mathematician, we're not accustomed to Hollywood making films about our heroes. And so when we were working on the film, one of our major challenges was to make mathematics seem like something that an audience consisting of non-mathematicians should be a subject that people should care about. So how do you do that? You don't bombard an audience with theorems or crazy formulas. There is some of that. And what Matt Brown did, I think quite beautifully, and I'll share a film clip in a moment, was to get across the idea that not only to Ramanujan, but to many mathematicians, certainly most pure mathematicians, that we like to think of our discipline as an art, the stuff of, rainbows and butterflies. And as hard as that may seem to believe if you don't work in the field, that's how we view our work. And so if I may, I'd like to show one film clip where the goal of this scene is, well, there were two goals in the scene that I'm about to show you. One was to indicate the absolute desperation that Ramanujan would have felt working in isolation. But to your question, the second goal was to illustrate how Ramanujan would find his work like art. So let me share that.
Yes, please.
Go ahead. You can look. Please.
What does it all do?
It's like a painting, I think. Only imagine it is with colors you cannot see.
What good is that?
Not much for you, I'm afraid. But for me, it is everything. maybe there is someone else who can see and understand it as well. And for them, it will be important.
Have you met them?
No, not yet.
I want to understand more than just colors I can't see.
What do you see?
Sand?
Yes? Imagine if we could look so closely, we could see each grain, each particle. You see, there are patterns in everything. The color in light, the reflections on water. In maths, these patterns reveal themselves in the most incredible form.
And so there you have that scene.
Yeah.
Lovely.
Lovely. The total engagement with mathematics, the amazement, it's really wonderful. Now I have a question for Professor Kaniger. Professor, can you tell us about your new book? I believe it's releasing in 2021.
Sure. It's coming out in April, and it's called Hearing Homer's Song, The Brief Life and Big Idea of Milman Parry. And it's not about mathematics and not about science, but I remember when I was at MIT, I was professor of science writing at MIT. Science writing, as I explained before, writing for ordinary readers. And I remember making the argument sometimes in class and sometimes with my colleagues that the idea of science writing can be applied to anything, inside science or outside science, wherever the material itself is difficult for the average person to understand. Not limited to science. And I certainly encountered that in this book, where I was dealing with ancient Greek, with the peculiarities of dactylic hexameter poetry used by Homer. And I had a hard time with it, believe me. And I did much of what I described to you before about approaching other experts in the field and really working hard to try to understand what I was seeing in front of me, and then reducing it to, I shouldn't say reducing it, I take that back, re-establishing it for readers who might not be interested in Homer, might not be interested in the Odyssey, might not be interested in the Iliad, might not be interested in ancient Greek, and yet to find a way to take readers into that world, the world of ancient Greek and the Greek epics. And that's what I was trying to do in that book. And it turns out, purely by accident, a pure coincidence, that there are some resonances with the Man Who Knew Infinity, with Ramanujan, that the person I'm writing about now was absolutely focused on his big idea. It was absolutely obsessed him from the time he was in undergraduate school and the time he went to Paris to work, to the Sorbonne, to work on his PhD. And in that sense, there's a similarity. And then unfortunately, there's another resonance in that he died very young at the age of 33 from a gunshot wound, which is still debated exactly how it happened. The way the police reported it later, it was an accident. It's not so clear that it was an accident. And one chapter of the book goes into the various theories for what that is. So the book is called Hearing Homer's Song, and it's coming out in April from the American Knopf.
And we're all waiting eagerly to read that book as soon as possible.
Yeah, so Shubha,
Yes.
just hearing Robert describe his passion for, telling these fantastic stories about intellectuals is exciting for me. When The Man Who Knew Infinity came out, the book, I was still a graduate student. I was still trying to figure out what I would make of my life. And so it's exciting for me to hear Robert tell the story of how he finds his stories, how he researches his topic, and crafts these wonderful books. Because, you know, I think one of the important messages that we have here in Ramanujan and in other scientists is that these people end up being role models for students and educators of today, right? There's a reason why the history of science and science writing is so important. And so it's a delight for me to hear that. If I could ask Robert a question, if I may, I would like to know how Robert first learned of the story of Ramanujan and decided to devote so much time to telling his story.
Ken, I'm afraid it's a very disappointing story. The story is that I had written one book before The Man Who Knew Infinity about about mentoring relationships in science, in pharmacology and neuropharmacology, called Apprentice to Genius. And I had an agent, a literary agent. And one day, Vicky Bajur calls me up and says, Rob, what do you think of writing a book about Ramanujan? And I think she said Ramanujan. And I said, who is Ramanujan? I had never heard of Ramanujan. It was completely foreign to me. But then I read that rather good documentary by, what is his name? Sykes? Letters, what is the title?
Indian Clerk.
From an Indian Clerk. Right. And I saw that. And then the realization came to me that, yes, this was a biography of Ramanujan, but also, remember, my book before then had been about mentor relationships, so I was primed for that, that in the story of Ramanujan and Hardy, the two of them, in that the tension between these very different figures had all the potential of being a glory. But anyhow, I had never heard of Ramanujan.
Right. Well, so actually, Shubha, maybe I could share one or two film clips that speak to Robert's message.
Yes.
But I wasn't aware of this previous book about mentoring in science. And one of the scenes that I'd like to share with the audience today is precisely on the interesting mentoring relationship between Hardy and Ramanujan. So, as is well known, Ramanujan came from India and Hardy was a professor in Cambridge, two very different cultures, very different communities, with very different expectations. Hardy was the professional mathematician. He was one of the first British mathematicians that strongly supported rigor in analysis. This was actually a turning point in theoretical mathematics from the 19th to the 20th century, the reliance on true rigor, which persists to this day and is important. And in Ramanujan, you had an amateur who didn't know what any of that meant. And so it's really quite remarkable as a story, as a true story, that Hardy recognized the potential in Ramanujan and overcame the many barriers that could preclude them from ever working together, and end up inviting Ramanujan to study with him. But because they were very different, one of the messages in The Man Who Knew Infinity, the film, that was important to us was to explain the very complicated relationship between these two men. How could Hardy explain to Ramanujan the need for rigor? Why would the world be better off if they were to succeed in this regard? And let me share with you a scene which I think beautifully portrays this issue.
How did you know that theorem?
It came to me. Mr. Hardy, I don't understand why we waste our time doing all these proofs. I have the formulas.
It's not that I can't see what you've claimed. It's that I'm not sure that you know how you got there. Or indeed that your claims are correct. There are subtleties which...
But they are right, sir. I have more important new ideas.
Yes, but intuition is not enough. It has to be held accountable. And a little humility would go a long way. Why do you think they want us to fail?
Because I'm Indian.
Well, yep, there is that. But also because of what we represent. Now, Euler and Jacobi, who were they?
Mathematicians.
Just names to you. Euler was the most productive mathematician of the 18th century. Most of his work done after he was blind. Jacobi, like you, was snatched from obscurity and was almost as impressive as Euler. Now, I think you are in their class. What they had in common, what I see in you, is a love of form. It's all through your notebooks. Let me ask you something. Why do you do it, any of this?
Because I have to. I see it.
Like Euler. Form for its own sake. An art unto itself. And like all art, it reflects truth. It's the only truth I know. It's my church. And you, just as Mozart could hear an entire symphony in his head, you dance with numbers to infinity. But this dance, this art, does little to endear us to certain factions who see us as mere conjurers. So if we are going to challenge areas of mathematics that are so well trod, we cannot afford to be wrong. I need you to attend your lectures, don't offend your professors, and keep doing your proofs. Otherwise, this experiment of ours will be doomed to failure. Come with me. I want to show you something. There are many ways to be honored in life. For us, being elected a fellow is certainly one, but in my humble opinion, to leave a legacy here at the Wren after we're gone is the greatest. This library houses the epistles of St. Paul, the poems of Milton, Morgan's Bible. But in my estimation, as a man of numbers, the pièce de résistance is Newton's Principia Mathematica. Now, just as Newton represents the physical aspect of our work, your notebooks represent the abstract. It took a long time for Newton to be proved, which is why we have an obligation to prove these. And if we do, I believe that one day, these notebooks will find their place here. Now, do you understand what's at stake here? Good.
That was beautiful.
I love that scene.
Terrific.
It embodies so much of what Robert was describing.
You have been a mathematical consultant expert consultant to the film, haven't you, Ken?
That's right. That's right.
So how did you ensure that the essence of the math did not get diluted when I mean, of course, there are powerful scenes like this, but how about the technical aspects of math? How did you?
So I'm very impressed by, and have always been impressed by, Matt Brown and the Pressman Film Company who produced this film. This was not about trying to make the next Imitation Game or A Beautiful Mind. The goal here was to tell, as best we could, the true inspirational story of Ramanujan. And everyone involved in the project, including the actors, really cared about telling the true story in a legitimate way. And so how did I help? Well, in pre-production, I helped the art department assemble the notebooks. If you were wondering, those notebooks were completely reproduced, not just a few pages. They were entirely reproduced by hand. It was incredible.
Really?
I had no idea how much work. I had no idea how much work goes into a film. So they made it snow in London. Okay, I thought that was magic enough. But in terms of reality, they reproduced several copies of the notebooks. There must have been a dozen or two handwritten replicas of Ramanujan's letters to Hardy. We had one artist whose only job was to perfect his handwriting. And so I participated in that work with the art department. And once we moved to rehearsals, perhaps the most exciting activity I've ever been involved in my career as a mathematician was those days that I sat down with Matt Brown, Dev Patel, and Jeremy Irons going over all of the script, several days. And to my surprise, certainly Jeremy Irons really insisted, so what's really going on in the scene? What is the point of the scene? And halfway through the first morning, he turned to me, and I was kind of, shocked to be in a room with Jeremy Irons. As a pure mathematician, this is not something you're trained to do. And he pulled me aside and he said, look, I'm not the mathematician here. I have to pretend to be a mathematician. And here, pull up your chair right up to the table, and we have to work through these scenes because we need your help to know how to talk like a mathematician. And I think I did the best I could, and it was fun. I should say there are videos, maybe even on YouTube, where I'm giving practice lectures to the actors talking mathematics. And, that was the level of detail that the project demanded. And
amazing.
I'm proud of that.
It was really showed in the film, so many scenes, especially when you're discussing on the board and writing down long equations. It must have all taken such a toll on the actors.
Right. Although I should say Dev was really quite funny about it. If you knew him, he's a very jovial, funny person, 24/7. And so it was funny in between shoots where he would ask people to quiz me, ask me if I know that formula, and he just recited it out loud. I mean, he was 24 at the time. This was several years ago. So think of, so I have one comment about that. If you've seen the Best Exotic Marigold Hotel films that Dev starred in, the character he plays in those films, that's really who he is. He's really that outgoing, that bubbly. And then you have Jeremy Irons, who's very professional, very serious. And that just watching the interplay between the two of them was really quite fascinating.
That's really a nice tidbit of information. I'd like Professor Kanigal to comment on one aspect of the film. How accurate was the you've actually researched Ramanujan very deeply and spent so much time with thinking about him. You would have had an image of Ramanujan in your mind. And how accurate was the portrayal of Ramanujan in the film, according to you?
Well, Dev Patel is physically different from Ramanujan. He's taller and thinner, and G.H. Hardy in the film is older than the actual G.H. Hardy. But those are trivialities. Those are real trifles. And from what I can see, and I came away deeply respecting Matt Brown's efforts in this direction, he was trying to make it as accurate as possible. Given that film is a different medium, even when you go from, you can have two people making a film or a TV program out of the same book, for example. We just watched The Night Manager by John le Carré, which had been done years earlier, I believe. And here we were watching a 6-episode series, a representation of John le Carré's book. It's a different medium. So if we're talking about accuracy, we have to keep in mind that a film is sometimes incorporating in a 90-second scene something that the author is trying to might take 10 pages to represent, and that in real life may be occupied several years. And there's an art in that. It's not easy. And if you ask for accuracy, how faithful is A to B. It's not, I think what a mathematician, correct me if I'm wrong, Ken, would say it's not one-to-one mapping between the two.
Right. It's a correlation.
Yeah. Can you comment on the same thing, Ken?
Well, first of all, there are many challenges. You know, we live at a different time. One thing I think that we should emphasize is that The Man Who Knew Infinity, the book and the film, is the Western perspective of Ramanujan. So I could imagine that if this film were, well, I could, right? I think audiences have to recognize that this is the Western perspective. If anything, it would be closer to Hardy's perspective. But to your question, how accurate is the film? I think it's remarkably accurate, certainly among Hollywood portrayals of important scientists. In terms of the mathematics that we just discussed, I think, I don't want to overstate this, but I think this film sets the bar for what is possible in terms of accuracy, in terms of telling the science, in terms of portraying.
And if I can,
yes.
If I can interrupt you briefly, you spoke of a Western, that this book and this film bring a Western perspective to the story of Ramanujan. And in a certain way, that's certainly true, but we don't have any trouble imagining that if 5 authors or 5 filmmakers were trying to tell the story of Ramanujan in film or in a book, each of those, even though they're from a Western perspective, or if they were from an Indian perspective, each of those would be telling the story in a different way as well.
Right, right. I agree with that. So getting back to what I was saying about the accuracy, in terms of how accurately the film portrayed life in Cambridge, say, in during the time of World War I, I don't know. I would have to defer to Robert and historians. But as far as I know, I think the film does a very strong job of accurately portraying true events. So in many films you see based on a true story, right? When you go to a theater, you watch a film based on the true story, and then you have to wonder, what does that really mean? I would be perfectly comfortable had our film said the true story of Ramanujan. I don't think that there are so many parts of the film that would stretch that description. Robert, would you agree?
I wouldn't agree.
Oh, you wouldn't agree?
The language. I think the language based on a true story is good language, because what is a true story? How do we know what's true in the first place? I don't mean to get excessively philosophical about it, but I think based on a true story covers any gaps between what we think is the reality of something and the story that we're seeing now. And to say that something in particular is the true story seems to be, to my mind, stretching things a little bit beyond where they should go.
What would be a better description? Because certainly, as we know, most Hollywood films that are based on a true story take far more liberty with the story than you have here in The Man Who Knew Infinity.
You could call it A Life of Ramanujan.
You could what?
You could call it A Life of Ramanujan.
Oh, you mean with the indefinite article?
Yes.
Yeah.
With instead of the definite article.
Yeah.
Yeah. I agree with Ken that this really goes beyond some of the other stories that Hollywood has taken on in conveying something like what we think is the life of Ramanujan. But you know, I like the language based on a true, even though it's been corrupted by others.
Right, right. I think we're in agreement there. So,
yeah. Ken, what is the significance of Ramanujan and his work in the 21st century?
Oh, wow. So I give lectures on this all the time. I don't know how much time we have. So in a nutshell.
Oh, you can take the next 3 hours.
Ramanujan's legacy is in one way very easy to describe, but in another very difficult to describe. Ramanujan was elected Fellow of the Royal Society at the very young age of 30 in 1918, based on the papers that he wrote during his stay in Cambridge. And by itself, that's really quite remarkable. He was the first Indian scientist elected a fellow. And if I were to describe that, I would tell you that his 30 papers have quite a citation list. They give birth to many areas of mathematics that people still perfect today. One in particular is the area of the circle method, which features prominently in the film. And that could be one answer. But if we were to leave it at that, the stuff that Ramanujan was famous for in his lifetime, I think we would be missing out on probably the most important aspects of Ramanujan's work, which is still ongoing. So in Ramanujan's papers, but more so in his notebooks, and a lot of this reflects work that's been done only in the last 10 to 15 years. You see seeds of some of the most important theories that modern day physicists and mathematicians are developing today. There's the gem of the idea that leads to the proof of Fermat's last theorem. It turns out that a French mathematician by the name of Serre, when studying Ramanujan's notebooks just by accident, discovered some formulas that sparked in his mind the idea that there should be a whole new area of mathematics called Galois representations involving objects that Ramanujan would have never heard of. Well, fast forward 30 years and you have the proof of Fermat's last theorem, that a to the n plus b to the n is never c to the n if n is at least 3, so on and so forth. There are other formulas of Ramanujan, in particular the work on his Mach theta functions that he did in his last year of life, which people didn't understand until 20 years ago. And in fact, Freeman Dyson, who just recently passed away, who's the very distinguished theoretical physicist at the Institute for Advanced Study. Robert, I remember, I think you interviewed Freeman for the book, and I think there's a passage about the Mach theta functions, and Dyson at the time said, yeah, it's poppycock that the Mach theta functions could be used in string theory, so on and so forth. Despite the fact that a few years earlier, he had written in an article where he was speculating that maybe someday on a lark, someone will find this connection. Well, I'll say, now this is one of the hottest fields in mathematics and physics. People who are trying to come to grips with the theory of gravity. Some of the best minds, Ed Witten at the Institute for Advanced Study, Jeff Harvey at Chicago, one of the hottest areas where people are studying black hole physics have discovered that in string theory, Ramanujan's Mach theta functions are now used to calculate entropies of black holes. Nobody was talking about entropies of black holes before Stephen Hawking. And when Ramanujan was alive, nobody knew what a black hole was. It was just some sort of singularity to an equation that physicists couldn't understand. But now we've taken photographs of black holes. So what is the relevance of Ramanujan today? It's this mysterious phenomenon that these 3 notebooks that Ramanujan left behind, full of some easy standard formulas, but also chock full of bizarre looking formulas, many of these bizarre formulas have been the seed of important fields. In terms of everyday life, one of my friends who's an electrical engineer at Caltech, his name is P.P. Vaidyanathan. He recently won the Kirchhoff Prize in electrical engineering. He studies signal processing. This is the mathematics and engineering of information transfer. Internet uses it, satellites use it, right? This is ubiquitous. And in his work, he discovered that a new mathematics was needed to solve some signal processing problems. It's in certain frequency ranges. And it turned out that the functions that he needed were found in Ramanujan's notebooks 10 years ago. And
fantastic.
Fantastic,
so
magical.
I don't know what else to say. He had this knack for finding formulas that had peculiar properties that decades or even 100 years later, scientists will recognize we need functions like this. and they've been in
I
these
think
on these
that's
yellow pages.
I think that's a beautiful point to bring out, that scientists and mathematicians do their work and they're not always thinking of what's the narrow functional use of it. Do you remember in the snippet that you showed, Janaki asked, what can you do with it? As if Ramanujan's mathematics would have some narrow, everyday plebeian purpose to it. And that's so often not the case in the immediate time, but 50 years later, 100 years later, in ways that we can't imagine, the work of mathematics and science billows out over the years.
Right, I couldn't agree more with Robert. This is a message for students all over the world, right? I invite you to get great grades and do well on tests, right? But the people who we should look up to are the people like Einstein, Newton, and Ramanujan, whose ideas really power generations of researchers that follow them.
Thank you so much. With that, we come to the last question that I have in my list. What, according to you, is the role played by the public engagement events like India Science Fest in bringing together science and society? Would Ken like to go first on this?
Would you like me to go? Oh, well, it's an opportunity for me to briefly escape the pandemic. I like talking about mathematics and Ramanujan, so thank you for having us here. For me, in a selfish way, it's great to see Robert again and be part of this engaging conversation. But to your question, these events are very important because, science, I think we need to restore the value of science in the world today, right? There's no denying that the world faces many challenges: the pandemic, the need for green energy, right? Climate change, right? The world faces challenges. And if there's one message that's really important to us in science, is that science has really played a central role in solving and overcoming major problems that humanity has faced over all time. And so activities such as the Science Festival celebrate that need. And I hope at this very difficult time, plays a more important role of inspiring the students and the professors and teachers to re-emphasizing this call to establishing or re-establishing the movement that supports science.
What about
and
you?
I think that the Science Festival and books about science and math, popular books, and film and cultural media in general have the effect of bringing science into the clubhouse. If you can imagine a teenage scene, a high school scene where the cool kids are in the clubhouse and the people who are not so cool are out of it. Science has sometimes, unfortunately, suffered by being outside the clubhouse. And I think Science Fest and movies and books can have the effect of reminding people that we're all in this together, that we inhabit one culture, and that all parts of it, from literature to music to art to science, are all part of the same thing. It's our culture.
Absolutely. I think we may have some questions from the audience. Shruti, do we have any questions?
We'll quickly do one question for Professor Kanagal and one for Professor Ken Ono, because we have received quite a few questions and we unfortunately don't have enough time to go through all of them. However, let me just ask the first question to Professor Ono. So the first question for you is, what drew you towards pursuing number theory?
Oh my gosh. The short answer is this. My father, who's still alive, he's 93, was a math professor at Johns Hopkins University in Baltimore. When I was born, I exhibited certain talent for mathematics, and they basically chose this career for me. I did my very best to not be a mathematician. That's a long story, but let me say, books like The Man Who Knew Infinity, the Nova television special that Robert spoke about earlier today, I watched that. And to add to Robert's point, these books, these films played a central role in helping me find my way, even despite the fact that my father was already a mathematician. So these things are important.
Wonderful. Thank you so much for sharing that with us, sir. So, Professor Kanagal, there's a question for you that says you have been a professor of science writing at MIT for so many years. How would you say science writing differs from, say, writing a piece of fiction? What is the difference between the effort that goes into both?
I don't write fiction, so I don't know. What I do know is that I've learned from fiction. I'd say 2/3 of my reading is in fiction. And one of the jobs of the novelist is to get readers to turn the page. One thing that novices to writing don't always understand is that the reader doesn't have to turn the page. He can close the book, toss it to the other end of the room, and he's not interested anymore. And the job of the writer of nonfiction, the job of the writer of science writing, is to take a reader who may have no initial interest in the subject and get him to keep turning the page, either through the human activity that you're writing about or the inherent intellectual appeal of the subject that you're writing about. One way or the other, get him to turn the page. That's what novelists do, and that's what good science writers do.
Oh, wonderful. Thank you so much for that. Quite insightful. Okay, so one question that we have received is applicable for both the professors here. So how much time did you both get to spend on the sets of the film, and did you think the overall ethos of the book got transferred onto the silver screen? Professor Kanagal, would you like to take that first?
I think overall it did. I was very pleased with the film. I thought Matt Brown did a wonderful job, and that he really took seriously the almost impossible job of bringing a little flavor for the mathematics to the screen, thanks to Ken in part. I think he worked really hard at it. What was the other element of your question? Oh, time on the set. My wife and I spent, I think, 2 or 3 days south of London, and then in Cambridge 2 or 3 days at Trinity College, where I also remember not snow, but rain, where the filmmakers made a rainy scene. And ever since, I've never been able to watch a film and trust that what I'm really watching is true rain. It's amazing the magic that they can bring to making films.
Absolutely. You know, the silver screen really does bring in a different flavor of magic into our life. Professor Onu, would you like to take that question?
Yeah, actually, I think, Robert, I think you and I, we just missed each other on set.
I think so.
Yeah, so I was on set maybe about 2 weeks from pre-production through a lot of the shooting in London. I wasn't involved in any of the other shooting, but after all the filming is done, there's still quite a bit of work, actually over a year of work. So I continued to work with Matt in terms of some edits, some reshoots, and then the task of promoting your film, which I was not prepared for. I had no idea how much travel is involved in film promotion. It was exciting, but really quite a bit of work.
Very interesting. Professor Onu, you and Professor Manjula Bhargava had been quite a significant part of the movie as mathematical experts. One of our attendees wants to know if you had a chance to collaborate with Professor Bhargava, and how was your experience?
Manjul, I've known Manjul for many years. He's a little bit younger than me, so I remember when he was still a graduate student and I was a young professor. Manjul came onto the project after the shooting had been done. He played primarily a role in film promotion. Do I collaborate with him scientifically? A little bit. We haven't yet written our first paper, but we're in the same field of mathematics. He won the Fields Medal in 2014, and I played some role in that process. Yeah, so I'm also a member of the IMU, and it was exciting to see a good friend win such a great prize.
Oh, wonderful. That was so nice to hear. Professor Kanigal, the last question of this discussion is to you, and our listener wants to know, are there any suggestions that you have for budding science writers and biographers in India? What would you say to them?
Work hard. Writing a biography can be a daunting task. And I think you need to constantly ask yourself, do you really know what you think you know? And all through the process. And don't stop with whether you're writing about science or writing a biography. Try to keep on asking yourself questions. Is this for real? It's a process. It's this, you're gaining an initial idea of your subject, and then that initial idea transmogrifies, it changes. If you keep on asking questions, and if you're not completely satisfied with what you've done and what you think you understand. So keep at it, and don't settle for easy answers. That would be my 30-second advice.
Thank you so much. I'm sure it was useful for all of our attendees. Shubha ma'am, any last thoughts before we end this session?
Well, that was just an excellent, wonderful discussion that I was privy to listening firsthand here. Thank you so much, Ken, and thank you, Robert. It was really very nice to have you here. Thanks, Shruti, for this opportunity. That's
it's
about
my
it.
real pleasure to have appeared here. Thank you so much to all of you.
Yeah, thank you, and have a good day.
Thank you, Professor Ono, Professor Kanigal, and Shubha ma'am, on behalf of the entire team at India Science Festival. We're so grateful that you took out the time to join us. It was an absolute honor to host you at our festival, and I'm sure that our attendees gained a very interesting perspective on the entire process that goes behind the representation of science and mathematics in literature and cinema. Something that, as Professor Kanigal rightly said, does not generally belong to the clubhouse, but really needs to, because science and math can be really cool if you think about it. So thank you so much. It was an absolute honor. And we do hope that the next time the festival hopefully isn't virtual, and that you actually get to celebrate the festival with us in India here.
That would be wonderful. Keep healthy, everyone.
Yeah.
Thank you so much.
Thanks
a
Have
lot.
a good day.
And to all our listeners, I'm just gonna quickly wrap this session up. Thank you so much for joining us. Today's been a very long and fruitful day. We've had talks and discussions going on since morning. We had some exciting workshops followed by sessions on robotics, healthcare, and space. And it was very, very enjoyable for me. And I really hope all of you also had a good time. The festival is going on till the 31st of January. So make sure that you head over to our website and get a good look at all the events that we have planned for you. Each and every event is free, so you don't have to pay anything to be a part of this festival. All we want to do is bring the voice of science to all of you, and we really want you all to join us in this process of celebrating science and technology. And do hope that you will join us, and make sure that you encourage your friends and family to be a part of these events. And hope to see you very soon. Our next event is on Tuesday. We're going to be interviewing an ex-NASA engineer, and it's going to be a very, very interesting session. I can assure you of that. Our events are themed around space, health, and robotics. We have general science as well as science communication. which again is very interesting. So our sessions are definitely something that you shouldn't be missing. And all you need is an internet connection, and yeah, you'll be we're very happy to have you all as our attendees, and hope to see you very soon. And